Good morning, everybody. It's time to roll. It's time to roll. How are you guys doing? Hope everybody's doing well. We should be coming up here on Rollout momentarily.
Discovery, go at throttle up.
I am here. We can start now. Artemis Rollout. XTC 64-month resub. Did you survive Flame Trench? I'm here. Am I not? Am I not here? I'm here. Hello. I got my SLS mug. I got my SLS shirt. I got my NASA hat. We're good to go. We're good to go here, man. I did not survive the Flame Trench. I am not in danger, Zyzep. I am the danger. I am the Flame Trench. No, I did a solo session of Flame Trench yesterday. Yeah, I just did my own Flame Trench. They everybody else is off on assignment, like covering the rollout or other things. So yeah, I was just like, oh yeah, I'll just do it myself. Whatever. All right. And it was a good one? Yeah, that's good. I am the Senate. First motion is already started. Yeah, here's a live shot. This is shot inside of the VAB or outside of the VAB. This is where this is positioned. This looks like it's a camera that's on the viewing platform of Operations Support Building 2 or OSB 2. That's the official NASA shot. It's not great. It's not great. That's that could be better. NSF might have something. They do have something. Oh yeah. There it is. So the crawler transporter down here is moving the mobile launcher, launch umbilical tower, and the Artemis 2 SLS rocket out of High Bay 3 here. Do you have your banana for scale? Of course I do. I don't know why it chromas the banana. That's not green. Maybe it's just not ripe enough. But hey, Moo, what's going on? Isn't it smaller than Starship? Yeah. So this is still a big rocket. Oh, it's B2. Much better than plywood 2. Oh, yeah. If you look, I mean, the crawler transport moves at a blinding speed of 1 mile per hour. If you look at the walls of High Bay 3, you can see that it is moving. She's moving. Oh, yeah, Zizef. Yep. Artemis 3 uses the new ML, right? Yes, the Mobile Launcher 2 is being built over there. It's that away. Oh. Thanks, guys. There it is. So that's Mobile Launcher 2. And this is Mobile Launcher 1. Oh, yeah, that's right. 3 is still... Excuse me. Sorry. It's early coffee time. Thank you, Phil. Artemis 3 is on this one. Artemis 4 is on ML2. Sorry. I got ahead of myself there. How fast will the crawler go? 1 mile per hour. What is it? Yeah, 1.6 kilometers an hour. Yeah, Joe, it's pretty good. That's Ferrari fast. Oh, come on, man. Why you gotta bring that up? How long is the crawler wait? It's about 3 miles to 39B. It will take about 12 hours. Yeah, I don't know if you guys can see the water truck right in front of the ML. That should give you a good idea of scale here. That's a pretty big truck, and it looks like a toy compared to this. This is just built on a scale that you have to see it. You have to see it for yourself. It's just like, it's like, you know, when we talk about like Boca Chica, you just kind of have to go see it. There's no getting around it. You have to go peep this thing. That's if the tower makes it. Yeah. Hey, morning, Chris. How you doing? Is ML2 a little taller for Block 1B? Yes. Just a little bit, though. .45 meters a second for the KSP, folks. Yep. There you go. There's a shot of roll here. Let me see if we can see it on the NASA view. I am kind of taken aback that NASA doesn't have NASA. This is the only camera that they put out. This is their live stream. That's it. The ML deck is 50 feet off the ground. Top of the mobile launcher is 355 feet. Yeah. That's 39B. In this shot, you could see the pad. That's where it's going. It's going over there. The crawler weight goes down there, and then it turns and goes up to 39B. Yeah. There's the water tower. Right there. Yeah, I don't know why they would use... I can't believe that this is the live stream. That's their live stream? Okay. Okay. How long will the rollout take? 12 hours. Look at that. Look at that dang thing, dude. Will you be here for the whole rollout? No. No. We're gonna be here for so we're gonna watch Rollout for a little while, and then NASA has a press conference at 9 a.m. that Jared Isaacman is going to be at, and the crew, and we'll watch the presser and then talk a little bit more about it. And then unfortunately I have stuff to I gotta go do stuff. I have to yeah. We streamed a lot of hours this week, which is great. And yeah, I gotta go do real life things. Come on, take one for the team. What do you mean take one for the team? So, all right, here. Little bit of stuff. So in case you guys don't know Complex 39, or you're not 100% sure what we're looking at right now, you've got some water trucks there. This grass, you see there's grass, but there's also kind of a rocky gravel pit right here. That's what the crawlerway is actually made out of. And I made sure that I had these things ready to go just in case anybody wanted to see. Check this out. That's what the crawlerway is made out of. These were gifted to me for educational purposes. The reason why these were gifted to me is, yeah, I mean, don't steal rocks from the crawlerway ever. The reason why these were gifted to me is because these were already compacted. These were rocks that were getting thrown away. Yes, you heard that right. The crawler way is made out of rocks, and the rocks actually get crushed as the crawler transporter goes by. If you notice this rock right here, this rock was your uncle's rock. No, if you notice, the top of it is completely flat because it got flattened by 16 million pounds of crawler. Well, it wasn't 16 million pounds of crawler at the time. It was just the CT, which is only like 1 million pounds. But whatever. They gave me broken stones. Yeah, see, these rocks were already crushed. See, this is Tennessee River rock. This is a type of rock that's found in Appalachia in the United States, in Tennessee, and basically along the... I want to say the Mississippi River, but it's the Tennessee River too, like, because it's called Tennessee River rock. This is what the crawler way is made out of. It's made out of these types of stones because they crush. They're porous stones. They get crushed. And that's what absorbs the energy of moving 16 million pounds or 7.2 million kilograms of rocket and launcher. That was the only way they could get, in the 60s, that was the only way they could figure out a way to get something to move, right? And not sink into the ground, because in Florida, the water table is extremely high. It is very swampy. So the rocks and an attract vehicle, the crawler transporter, right, which is down here, it lifted that whole dang thing up off of its pedestal in there, and it's moving it to the pad. This was the only way that they could do it without it sinking into the ground. The crawler transporter is basically a kit-bashed piece of mining equipment. It was made by Marion Power Shovel in Marion, Ohio, who made mining equipment. They don't exist anymore, but... How often do they replace the rocks? The rocks need to be replaced every 3 to 4 rolls, because once it compacts too much, the CT will sink into the ground. Yeah. Especially if it's moving a rocket, dude. You can see the SRBs. Oh my gosh. How deep is the rocks? The rocks go down 1 to 2 feet, and then there's a subgrade under there. Once again, it's all designed to disperse load, because I don't know if you guys could tell, that moving skyscraper right there, that's kind of heavy. It's pretty heavy. And weight does have something to do with it, because we're talking about stuff on the ground here.
Discovery, go at throttle up.
Dragon, what's up? So, why are we covering this? That rocket, the rocket that's on there, you could just see it. It's orange. It's orange! Orange and white on the left, right here. That rocket, if you don't know, that's the Artemis 2 Space Launch System rocket. That rocket is the first rocket that's going to send people beyond low Earth orbit since Apollo 17 in 1972. There's a shot of it inside the VAB. Oh my gosh. I'm sorry, I zoned out. I'm damn. Oh, Goalie, I'm actually going to use that picture.
Discovery, go at throttle up.
Here, guys, you want to see? You want to see? This is from the. This is what it looks like from the deck of the crawlerway here. Or the deck of the mobile launcher. There's 2 lanes for the tracks, right? And you can see where the compacted rock is. Those are some of the rocks that I got. These rocks are okay. But yeah, you can see where the CT was driving. And it's cool because in this picture, you can actually see High Bay 3 with Mobile Launcher 1 inside of it. That's the one that's moving today. And then over there, see that building? That's OSB 2, Operations Support Building 2. That's Operations Support Building 1. That's the Launch Control Center, where they control the launch, and then this is the Vehicle Assembly Building. In the background there, you could see the former OPF 1 and 2. The camera, NASA's camera, is from this. See the deck right there? The viewing platform? That's where this camera is. And we still can't see the rocket. February 6th is the no earlier than date. And then over here, if you see that building right there with a shuttle-shaped hangar door on it is the former Orbiter Processing Facility 3, or OPF 3. That's actually where Starliner is assembled. You can tell because of the way it is. And that's a Toyota Corolla right there. Yeah. Yeah, now you know. So if they zoom out a little bit more, that's all the Starliner's build and processing facility there. It's called the C3PF now, the Commercial Crew Processing Facility. I love the VAB. That's such a cool building. I am very envious of people that get to work in there. NASA's Vehicle Assembly Building is a 4-high bay stacking facility for processing and building super heavy launch vehicles. It was built for the Apollo program in 1965. Every Saturn V ever assembled was built in here. Not necessarily in this high bay. There's 4 of them. There's 2 facing to the east and 2 facing to the west on the other side. Every single shuttle stack that launched was built in this building. And now the second SLS is rolling out from this building. It is an awesome structure in the very literal sense of that term. The VAB is 525 feet tall. It's a little over 150 meters. It is a 52-story building. It's gigantic. It is a processing hangar for these things. The mobile launcher right there, 355 feet tall, or a 35-story building. That's pretty nuts, man. And the VAB makes that mobile launcher look tiny. It is not tiny. Did you know that there's still Apollo flight platform hardware in there? Yes. I know exactly where it is, Goalie. Inside of the transfer aisle. In these facilities here, there's S4B processing stools. There's 4 of them. Yes. We should use those. Thanks for being here. Hey, thanks for watching, Run. Yeah, the VAB is 52 stories. If you look right here, you could see that it's basically a metal lattice structure, right? One of these X's, if you look, see you have cross beams right here. One of those is 3 stories tall. So you can see that's just a regular walkway right there. And there's 3 of them that comprise the inside of each truss structure. Up here inside of the VAB, you have processing platforms. These servicing platforms. They actually move in and out of the sides of the high bay to gain access to the rocket, so you could, they move together and you can actually work on the thing. They retract when they go to move the rocket out of the building. Why are there no windows on the VAB? Mr. Neb, it's a hangar. For what it's worth, hangars don't really have windows. Second of all, that's not actually true. It does have windows. That is a window. It's one of the biggest windows you've ever seen. Here, let me see if I can find a picture of what it looks like on the inside when the sun is shining through that window. I should have something sitting around here for your viewing pleasure. Oh, I do have this picture that I'm just going to show you. That's a Saturn V being built in one of the high bays. Okay. I think that's Apollo 4 if I'm looking at that right. I need this shot of SLS, please. But yeah, it's okay. Let me find a picture of inside the VAB. So there actually is windows, even though it doesn't really look like it. But one, like I said, there's no windows inside of the high base. The windows are in what's called the transfer aisle. Give me a second. I have a lot of really, really nice pictures of the... Ooh, there's a picture of the VAB under construction. I'm keeping that one. Give me one moment. So, I'm telling you...
Discovery, go at throttle up.
The VAB is something out of science fiction. It looks like something where we would be building like huge mechs. But here, check this out, man. Neb, take a look. That's when this is a picture from when NASA was installing new gantry cranes inside of the transfer aisle. But see, that grayed out part on the sides, windows. But dude, look at the scale of this freaking building, man. I love talking about the VAB. It is truly on another scale. Like, you don't realize how big this thing is until you go and see it up close. And you can do that with KSC tours. They'll drive you by it if you go down there. Anybody can go on a bus ride around KSC and take a look at this thing. It is ridiculous. Close enough? All right, Rockets. Let's see what you got. What you got for me? What you got there, Ben? Your name's not Ben. I mean, it might be. Oh, dude. Oh, I love it.
Discovery,
I love it. Hey, S, what's going on? 88-month resub. Hey, Outdoorsman, what's going on? If you were at a presser, what questions would you ask? What question would you ask Jared, and how long will they pause for photo ops? I think they'll pause for a photo op when the press conference happens. Hey, Muffin. Good morning. Sorry I'm late. Any space news today? Nah. Ashap, 96-month resub. Thanks, man. Baby. All right, let's go back over to the live views. That's from NASA. And this is from NSF. They have to pause for 45 minutes to retract the crew access arm. That's correct. That's what they did during Artemis. Yep. I'm going to be asking, is it possible to visit with someone who's talking about the story of this facility? Good morning from France. Yeah. So at Kennedy Space Center, Bob, you can get a tour, a bus ride tour around from Kennedy Space Center Visitor Complex. You can get a bus ride tour, and they will tell you. The bus is a guided tour, so there's a guy on the bus telling you what everything is. I mean, I'm not going to sit here and tell you that, you know, if I was on the bus, you'd get more information, but the tour guides down there are pretty damn good. When will the launch be? Quack, we're looking at February 6th. So the rocket needs to roll out to the pad, right? She's going to roll to the pad, and then they have to do testing. They have to basically plug this thing into its launch pad and make sure that everything works. And then they have to do a couple of what's called a wet dress rehearsal campaign, which is basically part of the testing is where they go through an entire countdown, fueling the vehicle, and unfueling the vehicle. They basically will go through an entire launch sequence, but will pause the launch sequence at T-minus 30 seconds. They do that to just make sure that everything is working on the vehicle. And then the pause at T-minus 30 seconds, they test the safing procedures for the vehicle. Because if you have a rocket fully fueled on the pad and, you know, you don't want to launch it, you have to figure out the off-ramp to safe the vehicle and make sure that it's called inerting the vehicle. So they got to go through the simulated countdown, and then they got to go through safing procedures. If everything goes right with that this testing campaign should be over the next 2 weeks. give or take. If they do all that and it works, February 6th is what we're looking at here. If you're running that bus, the tour would take all week. People would get their money's worth. That's all I'm saying. Why is it so slow? It's 1 mile per hour, zombie. It's slow because the launch umbilical tower, which is this gray structure here, the light gray structure, and the mobile launcher platform right here, the LUT and the MLP form the mobile launcher. The mobile launcher combined with the stack, right? Because those are fully fueled SRBs. You can't fuel the SRBs on the pad, right? There's a solid rocket booster. It's a big Estes rocket, right? Big Estes rocket. It's actually the Northrop Grumman rocket, but you know, we can say Estes rockets, whatever. All that weighs about 16 million pounds. You are quite actually moving a skyscraper in terms of mass and size. To be honest with you, dude, 1 mile an hour is actually pretty damn quick for moving that much stuff. This thing is gigantic, dude. How fast does the Starship booster go on the SPMTs? I don't know, like maybe 5 mile an hour? But the SPMTs are not moving something this heavy, dudes. Oh, baby. Look at that monster. How long does it take to fill the entire rocket with fuel? Couple hours, Badojo. Fueling, we went through the entire countdown sequence on Flame Trench last night. That's basically what I did. I just did it. I made it basically an Artemis 2 Q&A because there was nobody to argue with. So we kind of just went through the countdown. They begin fueling everything. Live event starts soon. Hey, guy. That's the upside down. That's Kennedy Space Center in the upside down right there. Yeah, it's breathable. You know, that's why nobody has masks on. Did you argue with yourself? No. I argue with myself enough up here. I don't need to do it in public, okay? But Ojo, so yeah, it takes about 2 hours to fill, but they start filling this vehicle up well before crew gets there. Yeah, that's for a couple of reasons. One of the big reasons is the liquid hydrogen. So the core stage, the orange part of the rocket, uses liquid hydrogen and liquid oxygen, and that's feeding 4 X space shuttle engines down at the base. For SLS, they're called RS-25Ds, right? But it's down there in the MPS. Right there, you have your hydrogen tank right there, and then there's an intertank, and then there's the LOX tank, liquid oxygen up at the top. But that hydrogen tank and hydrogen just in general is very temperamental. It's you kind of have to slow fill everything, or else hydrogen will leak. What's that stack gonna weigh at liftoff? 8 million pounds, which is like I'm gonna guess that's like 3.8 million kilos. That's crazy, goalie. Hang on, so right there. I mean, once again, you want to get scale, look at the people standing on this thing. Can you imagine standing on a skyscraper that's moving? Right here is the access deck. That right there, this structure right here is called the Crew Access Arm, or CAA for short. This is where the astronauts walk to get into the Orion capsule that's inside of the launch abort shroud. This thing right here is a big rocket that's called the LAS, Launch Abort System. That's the ejector seat in case something goes wrong. But instead of just ejecting seats with the astronauts in it, it pulls the entire capsule away from the rocket. And Orion, the spacecraft that the astronauts are going to be flying on, is inside of that shroud. And they have an access arm to be able to get to it. All these other umbilicals here are fueling and gas scavenging systems for all the different parts of the vehicle. But that one right there, that's the crew access arm. Look. Look at the very top. You can see people standing on top of the ML. Once again, ML is mobile launcher. It's basically a launch pad that they can pick up and move. And in the background over there, that's ML2. This is what's going to be used to launch the next version of SLS. The next version of SLS will still have an Orion capsule at the top, but it's going to have a much bigger upper stage to be able to move much bigger things out to the moon. ML2 over there is designed, they basically had to rebuild it so to be able to carry a much bigger rocket. SLS Block 1B, the next version, I mean, SLS is pretty tall. It's a pretty big rocket. It's about 300 feet tall, about 100 meters. Block 1B is up here somewhere. Would be, if you stacked it next to it, it's up there. It's a big rocket. Now, Block 1B is about the same size as a Starship stack, and that Starship stacks are not small, okay? Do they pressurize the tanks with inert gas during rollout? Absolutely. How far into T+ can the LAS be able to work? There is no, Radio Galaxy, there's no blackout with SLS and Orion's launch abort system. They can abort at any time. They can pad abort, they can abort at max Q, they can abort all the way up to SRB separation. There's no blanks in the abort window. Anytime, basically. Once the LAS is armed, you're good to go. Don't ask how much ML2 is going to cost. It ended up being a little bit expensive. Dead Scum, I will say this once, I'll say it again, dude. I think that ML2, there's a reason why ML2 is carrying such a heavy price tag. The reason is because the crawler transporter and the crawler way can only take so much weight before the rocks will get crushed and it'll sink into the ground. Now, look, Bechtel is the prime contractor on ML2. I'm not saying that, I mean, like I said, the rocks will get crushed and it'll sink into the ground. I'm not trying to say that they're not at fault here wholly, but SLS Block 1B is a lot heavier because it's got a way bigger upper stage, right? And you have an upper weight limit to the crawlerway before it starts sinking into the ground. With Mobile Launcher 2, they had to simultaneously make the strongest mobile launcher to be able to hold up the heaviest rocket that NASA has ever launched, and also make the thing light enough so the crawler transporter can move it. That's why ML2 is carrying such a heavy price. Seriously. It's not all Bechtel's fault. And don't get me wrong, I want to harp on Bechtel just as much as the next person. But if you look at if they show a shot of the two MLs next to each other again, you can see that this is an entirely different architecture, structural architecture than this. It was completely redesigned because this needs to be light because the rocket is heavy. And you have an upper mass limit for how much you can move. So if the rocket is going to take up more of that weight, you have to completely redesign the ML to be stronger and lighter. It's basically an aerospace grade skyscraper. Crazy. The other reason why they had to completely redesign the architecture is because ML1, believe it or not, is bending. It's not a big deal. It's been reinforced. But when they first built this thing, right, it was the Ares 1's mobile launcher. And then they retooled it for a much larger launch vehicle. And it can't take it. It couldn't take all this extra stuff hanging off of it. It was actually deflecting. Now, once again, NASA has actually corrected it by strengthening this thing. But the strengthening for this type of mobile launcher architecture will not work with a bigger rocket. The whole thing will become too heavy and the crawler transporter can't move it. So they had to refactor everything with the mobile launcher to get it to hold itself up, and the heaviest rocket that NASA's ever designed. Yeah, it's not entirely Bechtel's fault. As much as I want to harp on them, it's not totally their fault. Yeah, it's not totally their fault. As much as I want to be like, yeah, they suck. It's not like, I know that's, oh, there's people waving off the crew access arm right there. It's not totally their fault. So, a little bit of a glossary on what this stuff is. This is the Orion servicing arm right there. It has all the commodities and all the power connections for the Orion capsule. Right below it, this thing is called the ICPSU, the Interim Cryogenic Propulsion Stage Umbilical, and that is the fueling and diagnostic, well, not diagnostic, it's the fueling mechanism for the upper stage, which is right here. Hey, Slimbo, 62-month resub. Thanks, man. This one right here is called a VSS. That's a vehicle stabilizer. It's basically a structural arm with shock absorbers built onto the end to make sure that the rocket doesn't tilt when they move it. Seriously, it's just a stabilizer that holds the rocket straight up. This thing down here is your it's called a HASGAS umbilical. This has the ground umbilical carrier plate for the liquid hydrogen or gaseous hydrogen recirculation system. This arm is designed to pull any excess hydrogen gas that comes from the tanking procedure away from the vehicle, because you don't want gaseous hydrogen sitting around. It'll make a big explosion if you leave it there. Any banana sightings yet? No, nothing. Liver Goose, that shirt is from my buddies over at NASA Spaceflight. NSF has the IKEA furniture merch right there. That's pretty good. It's a good way to say it. Yeah, it's at shop.nasaspaceflight.com. So it prevents the twang. Outdoorsman, it's not really used during launch. The VSS separates during ignition with all the other umbilicals. It actually, it doesn't move to the sides. The VSS actually folds down. This thing will go down this way. Hey, Matt. Flight controller for 5 months. Thanks, man. What's going on? I read somewhere that the old Alcos are going to be displayed at the KSC Visitor Center. What are those black squares on the rocket? The checkerboards there are for, well, cameras. So, Adrian, have you ever seen a car crash test? You ever seen the crash test where they plow a car into like a steel plate and the thing crashes? You ever seen one of those? They have those checkerboards on it, right? Now, what does that mean? Are they going to crash this thing into a steel wall? Well, I really hope they don't. That would be really bad, especially with people on board. Probably shouldn't do that. But those checkerboards there are to, like when you're filming this thing with a camera, they're there for reference positions to make sure that nothing moves. Like you can actually film this thing, and then if you measure the distance between these points, right, you can see if anything is moving around. They're for camera instrumentation. That's because when SLS launches, NASA's going to have 1,000 cameras looking at this thing, and they want to really, well, you know, SLS has those 2 side boosters. You want to make sure those side boosters don't do anything like this. And that's what these are. That's what those checker marks are there for. They're there for camera instrumentation to see if anything is moving around that shouldn't be. Oh, look. You guys check this out. We have it was just linked to me from one of my buddies. There's a shot from on top of mobile launcher too. Nice. There's the power boom. Yeah, that's pretty good. Thanks for showing me that. That crane is ridiculous. It is. Does the crew access arm swing away if the launch abort system is activated, or would they push it out of the way? So, Hinris, the crew access arm will be retracted when the launch abort system is armed. The CAA will be moved into a position away from the vehicle. Yeah, for all mankind, pushing it away, like, no. No, I won't do nothing like that. I have friends in high places. Yeah, right? Yeah. Yeah, that's true. Yeah, that camera shot that I just showed you was taken, that picture that I just showed you was taken over there. There's that crane, the Terex crane. You can see the water truck is spraying water around. That's to keep the dust down when this thing moves. That's the feds. See the blacked out SUV? That's the feds. That's DEA right there. See that? There's DEA right there. 23 cars in a boat. How did you wreck a boat? No, there's the DEA and the feds? Yeah, right there. See that? That's DEA vehicle right there. Right there. Don't mind me. It's still early, okay? I thought it was the Men in Black. Third field. Men in Black don't exist. What's wrong with you? You said no blackouts during the launch abort system. What about Max Q? Yeah, there's no blackout during any point during the launch. That includes maximum dynamic pressure. What do you think I meant? What about Max Q? Yes, they can abort during Max Q. Yeah, I don't know why the camera keeps doing that. Let me see if... Yeah, I'm not sure why that's doing that, but it's all right. Look at Reed Wiseman's. Okay. Oh, yeah. Yeah, I don't, Oh, wow. That is a nice. That's a nice picture. Yeah, there's ML2. There it is. There's the big lattice crawler crane. What is that? That's a Liebherr 13,000, right? That's actually really cool. That crane was used to make Starship's pad. This crane, if I'm remembering correctly, made Starship's pad, and then they moved it here, and it started making SLS's pad. Good stuff. That's what it is, Bedojo. The Sarin CC 8800. Yes. That was the name of it. I knew it wasn't the 13,000, but it's 13,000 would be its Liebherr equivalent. That's a Sarin's crane. It's different. But man, is that crawler the same? Is the crawler the same one that Saturn V had? Yes. The crawler transporter? Yeah. Mm-hmm. That CT, Crawler Transporter 2, moved Apollo 4 to the pad. Yep. Crane belongs in a museum. I disagree, Warhammer. I think the crane should be used to build more launch pads. Slogo, I think SLS 1B will happen. Yes, I think it'll happen. I think it needs to happen more. Dudes, like, once again, I understand SLS carries a heavy price tag. The reason why it carries a heavy price tag is because we only make one a year. That's not okay. That's not good enough to explore the moon, in my opinion. Really, that's not good enough. Four times a year. That would be the golden number. And in order to do that, you're going to need more rockets. That's my biggest thing. We just need more, build more SLSs, and the price will go down. If you buy in bulk, price goes down. And I think Rook will make that happen. I really hope so, Rev. I really hope I know he really is about leveraging commercial, and that I'm cool with that. That's fine. But I really think that scaling up SLS and getting like 20 to 30 flights out of the dang thing, at the very least, is it's a good enough way to ensure that we'll be able to not have a stopgap between like in-house NASA rockets and the commercial market that will emerge in the future for space. I don't want them getting, and I know you don't either, I don't want them getting rid of this thing until we have a commercial alternative that is signed off by NASA that can do exactly what that rocket can do. Right now, there ain't no commercial alternative. Starship works, and it will work eventually. But I don't want to wait around to, I don't think we should wait around, right? To whenever Starship gets its stuff together. Because, I mean, that iterative design takes time. You know, it is fast, right? But this thing works, and it works right now. Let's use that. We should use that for a little while, just to make sure there's overlap. Crawler versus wheel maxing, SPMT disgrace when. SLS isn't going to launch 4 times a year with how long it takes to assemble. I think, yeah. So, Mats, I have a personal theory about this. I honestly think that part of the reason why SLS is carrying a big price tag is because they designed all of its production lines for scalability. I'm serious. If you go look at how they set up the tooling for it at Michoud, and there are public pictures, right? If you look at how they set up the tooling, if you look at how they're working on the core stage processing flow nowadays, it's an assembly line, and it's designed for scale. The next thing that really needs to be done is they need to retool High Bay 1 for SLS as well. That's not good. This is High Bay 3 right here. High Bay 1 is the parallel bay to it. If they can retool High Bay 1 for SLS, I'm pretty sure the rest of the assembly line or the rest of the processing for SLS is all scalable. The real thing is just you need another high bay if you want to do 4 launches a year. And I think that could happen. I think Rook is the guy to make that happen. Yeah, there you go, Rarest. Exactly. I honestly can't wait for Starship to come to the Cape. More rockets. Yeah, Rev, I'm with you. Yeah, like I said, I'm not like an SLS fanboy or a Starship fanboy, or I just want more big rockets. Like, screw me, right? Like, why did NSF just go offline? They should be back up and running now. We need an extended 6 high bay VAB. Yeah, I like you, Boreal. Personally, I think that using high bay 2 and 4 for SRB staging and core stage processing is a huge waste. But Just my opinion. If I had it my way, keep in mind, my way means NASA gets a lot more money. I would modify the transfer aisle. I would build core stage processing stools in the transfer aisle and perhaps make this building a little bit taller to accept core stage processing and use the 4 S4B processing bays in here, extend it upwards to be able to process 4 core stages at once, and then utilize the high bays for what they were intended for. Because once again, I think that using, so where the American flag is, right, you see there's another door over here. This diagonal piece, that's the door. There's 2 high bays that face west and 2 high bays that face east. Okay? High bay 3 is the one that's behind this high bay right here. That's high bay 1, or HB1 for short. High bay 1 is still retooled for the space shuttle, which has not flown in 15 years. High bay 3 is retooled for SLS. High bay 4, which is on the other side of high bay 3, or high bay 2 right here, right? So it's 1, 2, 3, and 4. They're both for processing and holding on to parts for SLSs to be built over here. I think that's way underutilized here. The VAB was designed to be able to build 4 Saturn Vs at once. Let's go. I want to see this thing put to work, man. Yeah, I know, Rev. I know what they did, but what do we use when we run out of shuttle engines? Liquidator, part of the biggest price tag for the SLS program was restarting RS-25 production with Aerojet Rocketdyne, or L3 Harris, or whatever it's called. Post Artemis 3, SLS will utilize the RS-25E, which is the expendable version of a space shuttle engine. And SLS Block 1B will use those. Those are actually super powerful motors. They're more powerful than these versions. And yeah, they're working on them right now. NASA put one on the test stand at Stennis the other day and had a pretty long test campaign, firing RS-25s. They're testing them right now. Noob question: have they got multiple SLSs under construction? Yes. We've seen parts out to Artemis 4. The Artemis 4 stack has begun construction. The Artemis 3 stack is all the parts for it about halfway built. No, Alex, I don't think so. Any idea how much cheaper they are than the older RS-25s? They're not cheap. RS-25s are not inexpensive. They will become... The unit price will go down over time, Sloga, if we buy a bunch of them. Turns out that making an assembly line for rocket engines is a little bit of an expensive thing to do. You could ask SpaceX, they'll tell you the same thing. You think scaling Raptor 3 production was easy and inexpensive? No. That's $1 billion endeavor just by itself. When is this launching? If their testing regime and rollout goes, if the rollout Lord Powder goes good and the testing regime goes good, February 6th is our no earlier than date right now. So, guys, that's like 2 weeks away. 2 weeks for people going back to the moon. That rocket is going to put people around the moon. They're not going to land. They're going to do a flyby just as a shakedown mission, right? Humans beyond low Earth orbit. That's happening. What languages do you speak? I speak 2 languages, English and bad English. What languages do you speak, Haunted? Yeah, Archie, they carry a little bit of a heavy price tag, but that's because of the low unit production cost. You have to make more of these things in order for them to get the price to go down. You guys remember, RS-25s are like 100, I don't know if it's 100 million a pop, Archie, but it is expensive. The reason why is because the unit cost, the way the government does contracting is, say it is 100 million. The $100 million unit cost is roped into building the factory for them too. It's total cost involved per engine. Not how much did it cost to just make the engine and send it over to NASA. How much did it cost to build the factory, to make the engine, and hire all the people to put the engine together and redesign the engine, right? And then assemble the thing and then ship it to NASA. That's why they carry a heavier unit price, because the government uses what's called TCI when they figure unit cost. It's called total cost involved. It's not just how much does it take to make the motor. It's how much does it take to build everything and then make the motor. Build the factory, all the tooling, all the people that they need, all the designers, all the engineers, all the technicians, right? That's roped into the unit cost because that's how Uncle Sam does contracting, right? That's how Uncle Sam does business. If we make more of them, the unit cost will go down. If we mass produce them, you could get RS-25E production down to, I don't know, less than 5 million a pop. Easily less than 5 million a pop. You got to make a lot of these things, though. That's why I want SLS to launch more, because they carry such a heavy price tag because they already built the factory. Factory's already made. Just make more. That's the whole thing with the SLS program. That's why it carries such a heavy price tag, because the price is total cost involved. That's why this thing costs like $1 billion to launch. It's not just $1 billion to put this thing together and get it to the pad and fly the dang thing. It's all the factories that needed to be retooled, all the people that need to get paid, that worked on that vehicle, all the astronauts, right? That's roped into the cost because like I said, that's how they do business, right? No cost is abstracted with NASA. You're getting the full total cost involved per unit, right? So if you're roping the factory construction costs into your unit price, which they do, if you make more of these things, your price will exponentially go down. That's why I want more SLSs. We basically already paid for the factory to build this thing. Just build more of them now. Check it out. They're retracting the crew access arm right there. Roll is going just fine, Vargon. They stopped the CT here, and the crew access arm is retracting. You're looking at a moon rocket. That's right, Powder. Yep. Yeah, Gareth, that's it, man. That was your point about ML2 cost. It's bonkers if it only launches one rocket, but if it launches 4 launches, suddenly it becomes more cost effective. That mobile launcher, ML2, costs about $1 billion to make. If you launch one rocket on it, it's, yeah, $1 billion a launch, easily. If you launch 4 rockets on it, it goes down to 250 million. Right? You get your money's worth. If you launch 8 on that thing, price goes down even more. You launch 10 on it, 100 million. And that's, see what I mean? Because you have TCI for rocket costs with NASA. The more you launch them, the more you're going to make money off. The more the price goes down, it'll get cheaper to launch over time, because you're over time you're paying for the factory construction. So think about it like this. If we block buy SLS Block 1B, or even Block 2, to the tune of, let's say, 40 rocket, not 40, we would want, yeah, if we launch SLS 4 times a year for the next 10 years, that's 40 SLSs, right? The unit cost of building Mobile Launcher 2, the price tag for it pays for itself after 40 freaking launches. Right? $1 billion, whatever. You launched 40 dang rockets from it. Don't worry about it. Yep, they retract the crew access arm during movement to the pad. The reason why they retract the CAA, guys, is because the rocket does move around. It moves around. It shakes a little bit when they move it. And they don't want it hanging into the crew access arm. You really don't want to slap this thing around. It is fueled. That's why if they zoom out down here, there's the vehicle stabilization system. It's a huge hook that holds SLS in place, but the hook is actually on shock absorbers to make sure that to dampen out any movement from the vehicle. Yeah, the VSS is down there. It's probably about 10 meters that way. You don't want to see it. Don't slap the rocket. Nopers. That's not a good idea. We don't want it. Do not hit the fully fueled launch vehicle. Well, it's not totally fully fueled, but the SRBs are. Here. We got a new post from the commander of this mission. Oh. Oh. Well, that's pretty neat. You said it's fueled with actual fuel or an inert gas for pressurization of tanks. Core stage is inerted right now. The SRBs aren't. There's fuel in those things, dude. The boosters, the solid rocket boosters are full of fuel. Do you really want to hit the $1.2 billion firework right here? I don't want to hit that. That's a bad idea. We should probably we don't want to. You don't want to do that. But like that's a lot of ordnance right there. That'd be Nader. That'd be like hitting a Mark 82 with a hammer. You really want to do that? I wouldn't want to do that. That's a bad idea. We don't want to do that. Good safety tip. I don't think you could pick a better commander than Reed. He's been great. Yeah, Reed's awesome, dude. Right now, Orion and the ESM fueled weight about 40% of the empty core stage. Quite top heavy. Figured the solids were. My question was about the core. Yep. I know. I know you knew that. I clarify for everybody else. Nader, I try not to have like coded conversations that people don't understand. Context there, I guess, would be a Mark 82 is a 500-pound bomb. You don't want to hit that with a hammer. The SRBs are bigger versions of that. You don't want to hit those with a hammer either. Generally, don't hit fully fueled things with hammers. Percussive maintenance does work in some applications. This is not one of them. Thanks for the safety tip. I'll keep that in mind for my own solid rocket fuel rockets. Yeah, see that. There you go. Now you're being safe. Victory. That's a very unhealthy thing to do. 10 out of 10 Navy ordnance. 10 out of 10 Navy ordnancemen agree. See? I know what I'm talking about. Kind of. Can you poke it with a stick? Depends. What can we hit with the hammer? You could hit the ML with a hammer. Just make sure you don't hit any of the important stuff. You could do that as a treat. I want to counter your thought about why 4 versus 2 crew binary. All right, first and foremost, dude, I said I didn't know the reason. I took a guess at it yesterday on Flame Trench. So I'm not really arguing any one way or the other. NASA chose 4. That's what they did. This rocket is not engineered like Dragon or Starliner. Do we think ML2 is topped out? It looks like it is, but I'm not sure. Doing that is sure to ruin yours and everybody else's day. We saw what happens when you drop an SRB with the Delta II launch. Yep. Well, The CAA is moving forward? Huh. ML2 structure is finished, just needs the supporting hardware. Oh, there you go. Okay, something went weird. They shouldn't be moving it forward. It should be retracted. So the crew access arm can, there, the hinge point is right there. It swings, and then if you look right there, that's the locking mechanism to hold it in the retracted position right there. So the thing will move out here, and this, it'll basically click into the structure like if you opened and closed the door. I have a super stupid question. There's no stupid questions as long as you're coming from a place of trying to learn things, Chaos. Don't worry about it. What's up? Why do they move the entire launch tower with this rocket versus moving the rocket to the tower? Good question. They're about to slap the rocket thingy. Oh no. Yeah, no problem. We can't have that. So Chaos, let me go over to NASA's shot here. So, why do they move the entire launch pad with Complex 39? Well, it's quite simple. When this was built in the mid-60s, up until that point, NASA had... Actually, let me just back it up a little bit. Yeah, here we go. This is a Saturn I launch pad. This is Complex 34. This is circa like 1963 or something like that. So up until that point, they had what's called mobile service towers. See this thing? You can see another one over there. That's the one for Slick 37. This is 34. The mobile service towers lifted up, and they were on rails, and they moved themselves over and sat themselves down around the launch pad. And then they built the rocket right on top of the launch pad. Yeah, straightforward. So this is a bridge crane right here. They lifted the thing up, they moved it all the way over here, they set the sucker down, and they rolled the rockets in, picked them up with the crane right there. You notice that the gantry crane can move over to here. They'd pick the rocket up, pull it in, drop it on the pad. That's how the earlier Saturn rockets work. Saturn 1 and then eventually Saturn 1B. When it came around to moving the Saturn V, okay, that's the Saturn V right there, they opted to move the entire pad. Why? Why would you do that? The answer lies right in this picture. The Saturn V is so ridiculously big, and then SLS with it. They're so ridiculously large. How are you going to build that on the launch pad?
Discovery, go at throttle up.
Building that on the launch pad would require you to make this thing mobile. Getting that thing to move, I would contend to say, is more challenging than getting that thing to move. Right? Straightforward enough? So they opted for this design instead. Instead of building the rocket on the pad, they made the launch pads mobile and the building stationary. Which makes a lot more sense when you're building at this scale. Because, yeah, it might be heavy to move this thing around, but I guarantee you that this thing weighs more than that thing. And once again, what's the name of the game in Florida? Florida's built on swamps, dude. There's only so much you can move before you start sinking into the ground. Right? So they decided to make the integration building, or the assembly building, stationary and make the pads mobile. Which is not a bad idea. That's pretty smart. It was entirely for application. Like that was the way to do it. Because, yeah, this is actually not that big of a deal to move comparatively to the entire VAB. The VAB is gigantic. Even if it was just one high bay, right? Trying to get one high bay to move, like I said, I guarantee you it's heavier than this. Oh, there we go. Access arm retract. That right there on the CAA is the white room. That is the clean room area. This is basically a sealed. It's not sealed right now, obviously, but it basically seals up against the launch abort shroud with this this thing right here, and the white room forms a clean area to make sure that no debris gets inside of the capsule. When they do go to launch, they move the CAA into position. They seal it up against the side of the rocket, and then an HVAC system positively pressurizes this. Right? They're constantly pumping air into it to make sure that no dust gets in there. It's basically like a surgically clean environment when they go to open the hatch of the capsule, because you don't want dust getting inside the capsule. You don't want like a bird flying in there or something. No debris, no nothing. You don't want like rain getting in there if it rains, because it rains in Florida. So whenever they have the capsule open, they seal up the white room and they pressurize it to make sure that nothing bad gets inside of the capsule that you don't want. Dust is the enemy for a spacecraft. But dust can get in it now? No. Well, yeah, in the white room, but they'll move the white room into position, they'll pressurize it, and then clean it, right? And then they'll open up the capsule. You don't open up the capsule unless the white room is like surgically clean. Right now, yeah. Right now, it's just open. Yeah, anything getting into the capsule that you don't want is called foreign object debris, or FOD for short. Thank you, Dead Scum. Yeah, Boreal, not to mention designing a structure to survive the launch environment. Yep. Look at this. This is the guy that's running NASA, by the way. Our NASA Artemis moon rocket's trek to the launch pad began at 7:04 a.m. Crawler Transporter 2 is slowly moving it on top of the mobile launcher, with the 4-mile journey expected to take about 12 hours. Watch a live feed of the move. Jared says, nice and slow, team. You break it, you buy it. All right. Yep. Okay. Don't break it. Yep. Is it heavy? Yes. Then it's expensive. Put it down. Yeah. Deadbringer. Exactly. Yeah. The SRBs. Mm-hmm. What's the size comparison from the VAB to the Gigabay? So Starship's Gigabays would probably go up to about here. The Gigabays are pretty big, but you got to remember, SpaceX's Gigabays are not designed to hold a fully stacked rocket. What they are designed to do is basically be able to move super heavies and subsequently Starships, which will probably end up being the same size in the end. Like on and off pedestals, so like you can lift them up, so they have some headroom, so it's not nearly as tall. For scale here, guys, a super heavy is about the same size as the SLS core stage. So SpaceX's first stage would probably go up to about here. So that's what I mean when I say the Gigabay is about 2/3 the height, 60% of the VAB. So the Gigabays would go up to here. They're not bigger than the VAB, but they're almost as big as the VAB. Yeah, they're only designed to move starships and super heavies around with a little bit of headroom above. How long is coverage going to be? NASA's going to do a press conference in about an hour. Actually, about 40 minutes. I'm going to cover the press conference, and then I have to go. I have to go after that. But yeah, CAA looks to be in the retracted position here. Yeah, VAB was phase 1 of the original design. Yeah, I know. Boreal, in some timeline, LC-39 is a 4 launch pad launch complex. And in some timeline, we have 6 high bays in the VAB. In some timeline. How do they move the pad? Railway tracks? Nope. It's a gigantic tracked vehicle, Chaos Slayer, called a crawler transporter. The crawler transporter, somebody already asked about it. It is diesel electric, guys. It is 2 gigantic diesel engines, basically generating power for 4 electric tracked mechanisms. The crawler transporter is a ridiculous piece of engineering. It's awesome. Here, I'll show you a picture of what it looks like. Check that out. Those are the CTs. You got 4 double-tracked trucks on each corner here, and then there's a space frame structure that holds this thing together. This thing also has adjustable ride height. So what the CT can do is this space frame structure right here, which has all your power mechanisms and everything, that's the diesel engines. The 2 diesel engines are transversely mounted right here and right here. It can actually lower itself, get underneath the mobile launcher, and lift the thing up and then move it. This was basically, think about it like a tracked SPMT. That's the size of, I don't know, like 2 tennis courts. If you took 2 tennis courts, put them together, it's about that big. It's pretty large. It's about the size of a baseball diamond.
Go at throttle up.
I mean, look at it compared to the truck right there. It's freaking huge. And it has less rust than the Coronet. Thanks for that. RT, 98-month resub. Rolling time, that's right. Yeah, you could see CT2. There's 2 of them. There's Crawler Transporter 1 and 2. They're using 2 for this one. 2 is under there. This whole damn thing can move. It's ridiculous. I love it. How many gallons to the foot does it do? If you have to ask, probably can't afford it. No, Archie, yeah. I mean, honestly, it's pretty dang fuel efficient considering what it's doing and the mass that it's moving. It's diesel electric, so yeah. The fuel tanks on the crawler transporter are not small, let me put it that way. Do you have any pictures of the crawler transporter being transported to the Cape? It wasn't transported to the Cape, B-Dean. They built them. They assembled them on site. They were built, I'll show you. So here's the VAB, right? That's High Bay 3. That's the one that NASA's rolling out of right now. That's High Bay 1. On the other side, you have High Bay 4 and High Bay 2. And if you notice, there's like a loop right here. The loop is so they could get at the second high bays here. High Bay 4 and 2. And if you look over here, you have the kind of pens right here where the crawler transporters are. You have CT1 and CT2 right there. And they were built right there. Yep, that's where they were assembled. And then over here, you could see there's 3 kind of 3 areas right here. This is where the 3 Saturn V mobile launchers were assembled. They were built right here. One of them, one of the high bay or the mobile launcher storage is holding a shuttle MLP. That's a shuttle mobile launcher platform. They use it for weight testing to be able to make sure that the crawler transporter can move this thing. That right there is mobile launcher 2. This is an older picture of it still being assembled. And then the middle bay, they have just a bunch of service and support buildings in there. So yeah, everything was assembled on site here. Everything was built right here. Pretty cool, man. Should build more mobile launchers. Should build like at least 5. What stops the launch pad from moving when the rocket starts up? Mass? Interesting thing, Chaos Slayer. SLS isn't actually bolted to the pad. It's just sitting on top of the mobile launcher right now. Yeah. It's not bolted down. What stops it? Well, the rocket isn't bolted to it. So yeah, SLS just slips off the launch mount. Yeah, it's not tied down. Seriously. The SLS is so ridiculously heavy because the solid rocket boosters, it's so heavy, it's not moving. That thing isn't moving. It's not moving off its launch mount, that's for sure. Yep, no frangible nuts on the SRBs, Deadbringer, for SLS. Now, why? Why is that? Well, they needed them for the shuttle, right? Because when the shuttle fired its 3 main engines, they were off kilter. They were on the side. So the whole stack kind of moved back and forth. That's why they bolted down the shuttle. SLS doesn't have that problem. 4 RS-25 engines are not going to be enough to hit anywhere near enough force to push this thing off the pad. So they didn't bolt it down. Why bolt it down? There's no point. Waste of time. Yeah, for launch. For launch, yeah. That's what I'm talking about for launch. It's tied down right now with the VSS and Rev. You said there's some there's some tie down bolts down here, but yeah, when they launch, it's just sitting on the pad, dude. Yeah, Drunard. So, okay, let me clarify. Guys, I was talking about launch, all right? Forgive me.
This is space.
Right now, it is tied down, but they'll get rid of all that. When they go to launch it, it's not bolted down. They just slips off the mount. That's much easier. Why would you add an extra step? Anybody going to this launch? Render Dad? I mean, plenty of people are going to be there. The Cape's probably going to be the busiest it's been in a long time. Yeah, Boreal, that's the other thing. Not a lot of people know that, dude. The bolts that held the shuttle down to the launch pad were only there to keep the thing on the pad when the shuttle engines fire. Even if the frangible nuts and explosive bolts for the SRBs, even if they didn't pop, when those SRBs ignite, it would just rip itself off the pad, even if they went or not. Yeah. Yeah, I heard about that. Yeah, it did that a couple of times, Deadbringer, yep. Kind of meant you or other friend streamers. Well, my buddies at NSF will be down there. Render, I don't think I can make it. I got too much going on up here, and I hate saying that. But, yeah. I'm not sure, to be honest, who's going down there, Render, and who isn't, but... You got 12 hours to get there. Well, the launch isn't going to be until February, so... When do you expect Artemis 3 to start stacking in the VAB? Probably the end of this year. Yeah, probably the end of this year. How long did it take to stack this one? They started stacking Artemis 2 well over a year ago. And don't get me wrong, guys. It is not because it takes a year to stack one of these things. They could have this thing built. The processing team down at the Cape, if they had all the parts for this thing, they could probably build one in a month. Maybe 2. The reason why is that there's really no reason to go fast right now. These are shakedown missions. They're test flights. And just like you're testing flying the rocket, every time you put it together, you're going to learn something new. You know, for the first, second, third try. Once you get into a rhythm, then you go. That sucks, Ernock. Yeah, rollout's going fine. Up. Looks like she's moving again.
Discovery.
Hey, Oscar, appreciate you bringing up early. Thank you. Tier 2, 67-month reset. My pleasure. Think HLS or Blue Moon will do Artemis 3. I think HLS will, Lemon Space. But I also think that okay, so if I was Jared Isaacman right now, I would want both landers ready by Artemis 3. Not because I want to use Blue on Artemis 3 or because I'm preferential to SpaceX or whatever. Having more landers allows you more flexibility in your mission architecture. So parts aren't made on site like Starbase. They're built all over and shipped to the VAB for integration. That's correct. The solid rocket boosters, belt fed, are made in Ogden, Utah, and then shipped here via train. That building over there is the RPRSF. See that little guy over there? The solid rocket booster rotating service and processing facility. That's where they bring them in via train, and there's a crane in there that picks them up off the rail cars, turns the SRB segments vertical, and then they bring them inside of the VAB for storage and then integration. The core stage is made in Louisiana by Boeing at their Michoud facility just outside of New Orleans, and the ICPS is made in Decatur, Alabama. It was made by ULA. Orion is made by Lockheed, and the Orion capsule is actually made down the street. It's made at Kennedy Space Center. The launch abort system is made by Northrop Grumman. It's made in Utah, and then it's Ogden, Utah, and shipped here. And then the service module for Orion is made by our European counterparts. It's made by ESA in Bremen, Germany. Yeah, they make the Europeans make the service module for this bad boy. Airbus makes it technically. Yeah, there you go. Yeah, that's made overseas. So some of the stuff is made on site, but most of it isn't. They're closing the doors on High Bay 3. Do you think NASA will ever make another reusable launch vehicle? Depends. So Nocturlox, I'm going to answer your question kind of vaguely. So read into it how you might see fit here. I think that NASA will build reusable vehicles in the future. The reusable vehicles that they build won't be for this planet. Is that a fair assessment? It's about the same here, Enoch. Last, please, if you want. What's up, Aaron? Small update concerning BF6. They have extended Season 1 until the 17th of February. Season 2 will introduce 5 new maps, new guns, gas attack at game mode when you're fighting while the enemy is dropping gas canisters on you. They're going to add an MH6. Ooh. New tanks and IFVs are going to be introduced with new guns. They've extended this season to apply all the changes since Vince Impella wanted... Changes that Vince Impella wanted before he passed away. Cool. We'll do more late-night Battlefield in the future. I'm just on a winter car kick right now. I wonder how long it would take NASA to retool High Bay 1 for SLS if they ever decide to. Fluffy, I would budget, timeline-wise, I would budget about a year for that project. It probably wouldn't take that long, to be 100% honest with you. Because when they built the first high bay, it took a lot longer than that for SLS. If it was me, I would retool high bay 1 for block 1B. And most of the processing stands, or the service gantries, for SLS are the same between block 1 and block 1B. It's just they're different for the top up there. Honestly, I wouldn't be surprised if we saw a contract awarded for High Bay 1 to be retooled for Block 1B sooner rather than later. Because right now, they don't have any way to assemble a Block 1B SLS. You could use 3 if you really wanted to, I suppose. But, yeah, I don't think they will. That's awesome, Baron. I saw that. That's funny. How is Crawler Transporter 1 doing? CT1 is fine, but Dynasty CT1 needs to be rebuilt to be able to move SLS. Crawler Transporter 1 isn't strong enough to be able to move something this heavy. That's why they're only using CT2 right now. So CT1 is basically sitting, which kind of sucks, but... They have the knowledge, plus they're working on to retool High Bay 3 for Block 1B. They already have contractors that could retool High Bay 1. Rev, honestly, I would just award the contract for the guys retooling 3 to also just build 2 of every processing gantry that they build for the upper stage and everything. And just, yeah, retool 1 at the same time. That's what I would do. I hope they do that. That would be really nice. Yeah, the NSF is showing their infographic. Two SLSs at the same time, man. You're dang straight. Always wanted to do that. They need a second high bay, Fluffy, and to be 100% honest with you, they need another mobile launcher. There, I said it. The contract for Bechtel to build ML2 should have been to build ML2 and 3. Just my opinion. How's the weather? It's cold here, but it seems to be pretty mild in Florida right now. It ain't going to cost $1 billion to build the second mobile launcher. If the first one cost $1 billion, most of the engineering cost is roped into that. So second ML would probably be material cost at that point and employee salary. So like if they build ML2 and it cost $1 billion, and to be honest, actually, you know, now that I'm thinking about it, guys, ML2 is a cost plus contract. They could just add an additional contract stipulation to build another mobile launcher for material cost. Yeah, you could absolutely do that. And I think we need to. There's no way you're doing Artemis 4, 5, 6, 7 with 8. There's no way you're doing that with 1 ML and 1 high bay. Well, let me put it to you this way. You could. If they do, I'll be really pissed. Because that means 1 launch a year. Which is... yeah, stupid. Yeah, Revel, that's what I mean. That mobile launcher has to be the strongest and the lightest ML we've ever made. It's basically an aerospace-grade mobile launcher. I mean, you've seen the dang thing. It's a completely different architecture. It's because that thing is freaking heavy. There's another strong front coming through tomorrow. How come NASA decided to give 39A and not B to SpaceX? 39A is much more historically significant. $39B was already retooled at the time when LS. There needs to be some historical context here. In 2009. 39B launched its last payload, or last rocket. It was the Ares 1 rocket. After that, NASA started retooling 39B for the Constellation program. They started retooling it for Ares 1 launches. Ares 1 launches would have gone back to building a mobile launcher, and not a mobile launcher platform. So they cleared out all the structures, right? The fixed service structure, the rotating service structure, all the shuttle equipment. They cleared it out. They built lightning towers for and a lightning arrestor system, right? And they reverted it back to how it was in the 60s with a clean pad design. The idea was that the shuttle would keep launching off 39A and Ares 1 would launch off of 39B. And when the shuttle got retired, Ares 1 would still launch off 39B and 39A would be retooled for Ares 5. So the idea is take one pad offline, right, 39B, keep 39A working, right, 39B comes back online, and then they retool 39A for the Constellation program. The problem here is that in 2011, they canceled the shuttle and Constellation at the same time. So 39B was already retooled for Constellation, and then they retooled it for SLS. And then 39A, they decided it would be easier to lease the pad out because of some bupkis obsession about making 39 a multi-user spaceport, which is the dumbest thing I've ever heard in my life.
Discovery, go at throttle.
They leased off 39A to SpaceX to save money. Guys, I'll be 100% real with you. I love SpaceX. I'm a huge SpaceX fanboy. I don't hide it. I hate that 39A doesn't have crawlerway access. It makes my spacetism brain go bananas. I really don't like that. By the way, I asked some people I know about Artemis 2 and they said they will not watch it and are not interested. I asked if they would watch an actual lunar or Mars landing and they didn't seem super interested either. Do you think people nowadays other than spacers would not care about Artemis? I really hope that's not the case. I think they'll care when it launches, Marcon. Canceling Constellation was such a bad move. Correct. So, after they canceled Constellation and the shuttle, NASA got this idea in their head that they want to make Kennedy Space Center a multi-user spaceport. The real guys for that is that, you know, NASA's budgets got railed so ridiculously hard that, you know, leasing different facilities around Kennedy Space Center to commercial contractors would be an ideal way to help offset the costs of maintaining all these facilities. The reality is that nobody except SpaceX is really pursuing super heavy launch, right? And even SpaceX wasn't pursuing super heavy launch for a long time. I don't like that NASA gave up a launch pad that's capable of utilizing super heavy lift capability to a rocket that is not a super heavy lift vehicle. Long story short, Falcon 9 launching from 39A looks weird, okay? It looks weird. It's way too much pad for way small of a rocket. You could have used something else, but NASA, no, we got to save money. NASA, we got to save money. Look at how fiscally responsible we are. Look at how fiscally responsible we are. What kind of freaking snake oil is that, man? You gave up one of your heavy lift launch pads. What are you, crazy? SpaceX easily just could have used the plethora of pads that they have to the south here at Cape Canaveral Space Force station. They could have used, the Air Force has plenty of extra pads. They could have retooled 5 of them for Falcon 9, but no. NASA has to pawn off their heavy lift launch pad for a rocket that's not used for heavy lift. Oh, man. I can't stand it. But, I mean, at least 39A nowadays is getting Starship, so that's cool. But it's not utilizing any of the crawler transport or anything. Tell us how you really feel. Oh, I will. Oh, I will. Give it a decade? No, Starship pad there is actually almost done, Conan. Yeah, at 39A, it's almost done. Seriously, it's easily over 75% built. But, yeah, I mean, I don't know. SpaceX could have done that anywhere. They could have launched Falcon 9s from anywhere. But, yeah, NASA decided they wanted to save money by pawning off a super heavy launch platform or a super heavy launch pad because, oh, we don't need that. It was really, really uncool. That was a really uncool thing to do. SLS costs more than Constellation. Fluffy, it's about the same. We incurred the same cost to do nothing. Well, to do not nearly as much. But, hey, at least we got something now. That's good. Positive vibes, dude. All right, we got something. Launch it more, please. Yeah, Rev, I don't... Like I said, that was... I think... Look, I love SpaceX. I love that they're using 39A. I love that we see Falcon Heavy launch from it. That's super cool. I think that NASA giving 39A away to SpaceX, their lease is like pennies on the dollar. It's ridiculous. It was a real blunder for our national space program. Yeah, that was a really uncool thing to do. But then again, canceling Constellation was a really uncool thing to do as well. So, but like I said, you know, we're here. It took us, it was a really roundabout way to get there, but we're here. They're watering it, belt fed, so it doesn't kick up dust, because when that thing moves over the river rock, it's crushing it, and it can make dust, and you don't want dust to get up in the track mechanism. $39B makes more sense to give away at this point. Though I get why they didn't at that point. Yeah. Rev, like, I never understood why NASA wanted to, we're going to make Kennedy Space Center a multi-user spaceport. It's a multi-user spaceport. Dude, Kennedy Space Center has a runway and 2 launch pads. Why would you want to make it a multi-user spaceport? Why? You're not going to be able to compete with price with the Space Force. Okay, little bit of an example. What do I mean by that? So, guys, just to the south of Kennedy Space Center is Cape Canaveral Space Force Station. It's the Space Force base at Cape Canaveral. It has like 30 launch pads. I'd say at least 30 launch sites. at the very least. You have Slick 41, Slick 40, Slick 37, LC 34, LC 20, LC 19, LC 18, LC 16, 15, 14, 12, 11, Slick 36, LC 46, LC 17, LC 5, LC 4, LC 1, 2, 3, and 4, LC 30, 32, and I think that's it. Those are all pads that are, most of those are actually open for leasing. Why would NASA try to compete with that? That's the dumbest thing I've ever heard. We're making it a multi-user spaceport. No, you're not. You're just pawning off our national space program. The infrastructure at 39 is underutilized. I mean, SpaceX is changing that with the Starship pad, which is great, but also... Fluffy, with only 4 hours of sleep, brain isn't working. Were you there when Das got drenched by the water trucks during a crawler move? No, I wasn't there for that. Yeah, Snarfer, there you go. So like I said, I love SpaceX. I'm happy with that someone is using 39A, because honestly, the flip side of this is that if NASA didn't lease off 39A to SpaceX, it would still just be sitting there doing nothing. And that would be just frankly depressing. Like, I get it. But yeah, it's, yeah, ridiculous to me. Are you going to go to the launch? I don't think so, Beltfed. I want to sit here and cover it with you guys. So Kennedy only has 2 pads, right? Kennedy Space Center has 39A and 39B. And 39A is not accessible by NASA. You can't roll a rocket to it. The SpaceX put their integration facilities right on the crawlerway, so you can't roll anything to it. Not that, yeah, the 30, yeah, Phil. 39C, what cope? Such cope, dude. Yeah, there you go, Rev. That's right. Omega was going to use the VAB and LC-39B alongside SLS. Yeah, that's right, Shortline. Yeah, that whole multi-user spaceport thing. And then Northrop Grumman didn't get an additional bajillion dollars from the Air Force for NSSL phase 2, and they promptly abandoned the program. And Northrop Grumman thought it'd be a better idea at the time. This was in 2020, I think. They thought it would be a better idea at the time to use Antares. Antares would be a cheaper solution. You know, Antares. The Antares 230 rocket with a Russian engine and a Ukrainian core stage. Yeah, hey, how'd that work out? Oh, not great. Yeah. Yeah, that's good. That's a good idea. I said it at the time, Rev. I was like, them choosing to lean into Antares is a bad idea. Yeah, but no. Yep. Nope. But look, dude, screw all that. Look at that thing. I mean, it would have been nice. Omega was a good idea, personally. I think that was a fantastic idea. Turns out that Northrop Grumman just used Omega. They used Air Force money to, and the money that they got from the launch services, Phase 1 launch services agreement for the National Security Space Launch contract. They used that money to engineer the carbon composite versions of the segmented boosters, and they were going to use it for Omega, and then they pulled out of the Omega program when they didn't get a contract, and then just used it to build the next generation SLS boosters. They basically milked the Air Force for $500 million. Yep. To basically fund the R&D for SLS's next-gen boosters. It's kind of funny when you think about it. Hey, Daniel, what's going on? How many people are involved with transporting right now? Well, I don't know. I'd say 50 to 100 people, maybe. Multi-user launchpad makes sense if you have common infrastructure and architecture between rocket manufacturers like we have with airliners. Yeah, that's what I mean, Lala. The entire multi-user spaceport thing was cope. But, you know, like I said, it happened the way that it happens. But either way, we're here. This is good. No, Brun. Not to my knowledge. So they got the crawler crew, security, and a minimum crew to keep the launch vehicle happy. There you go. How fast is it moving? 1 mile an hour. I once heard that the crawler transporter can only turn like 10 degrees. So how does it make the turn around the VAB or toward 39B? Well, you could see the turning radius right there. This is about as sharp of a turn as the CT can make. Now, Mats, let's check the radius here. Let's go from center point to here. That's a 200-meter radius. Actually, it's got to go this way just a little bit. Right there. Yeah. The turning radius is not great. It's more than 10 degrees. That's how sharp it can turn right there. Yeah. I think a battleship has a better turning radius than that. When's the presser? It should be starting up like right now, actually. Yep, there we go. So if they drop anchor, it'll turn faster? Oh, yeah! I don't understand multi-user space facility when most of the pads are not clean and they're only using one private launch company per pad. That's the point that I'm trying to make, Dynasty. Multi-user spaceport is just a bunch of cope. That was like a multi-user spaceport. Now, don't get me wrong. It's not just the launch pads. To be very clear, they wanted a multi-user spaceport. So the shuttle orbiter processing facilities, OPF 1, 2, and 3, they wanted multi-user spaceports for that. So, so they leased out OPF 1 and 2 to Boeing for the X-37 program. The X-37 hangars are just behind the VAB. It's the old shuttle processing facilities. And then Orbiter Processing Facility 3, they leased out to Boeing for the C-3PF, for a Starliner. So, you know, that multi-user. Yeah, very multi-user. So, SpaceX and Boeing. That's all right. Yeah, Hawks, exactly. All right, here we go. Let's see what this press conference entails. And as is tradition, it very much seems like NASA's sound is superbly underdriven. So if you'll excuse me for a second, I will rectify their mistake. Guys, this is making me want to play KSP. We gotta take a day next week and play KSP. We have to. This is making me want to. Make me want to play this. It's called Volume Booster, Hawks. Super useful, dude.
What you're seeing is a live view of NASA's Artemis 2 rocket. We are slowly but surely rolling out to the launch pad. Good morning, and thank you for coming out here today to witness this monumental step ahead of our return to the moon. This morning, as that happens, I am joined here by the Artemis 2 crew, NASA astronauts Commander Reed Weissman, Victor Glover, and Mission Specialist Christina Cook, and CSA astronaut Mission Specialist Jeremy Hansen, as well as NASA Administrator Jared Isaacman. With that, NASA Administrator Jared Isaacman.
Thank you. Good morning, everyone. Thank you for coming out to witness this historic moment. Before I turn it over to the real stars of the show here, the Artemis 2 crew, I thought I'd take a moment to just share a little bit about the journey that we're on right now and President Trump's vision for American leadership in space. Now, this all began, call it just about 9 years ago. President Trump established the Artemis program, committed America to returning to the moon. Now, none of this should be a surprise. This is the president who created the Space Force. This is also the president who oversaw, during the last year of his term, the return of American spaceflight capability here to Kennedy Space Center after nearly 10 years from when the shuttle was retired. Now, I can tell you we're off to a little bit of a slow start here. We've got about 12 hours to go, approximately, before the Artemis 2 vehicle will make its way over to launch pad 39B. Now, from there, things will start to pick up the pace a little bit. So we'll put it, and we'll have technicians put it through its motions. We'll ultimately get to wet dress, and then from there, this vehicle, along with about 8.8 million pounds of thrust, is going to accelerate the Artemis 2 crew here to near-Earth escape velocities, so just under 25,000 miles per hour, farther into space than we've ever sent humans before, around the moon, back here safely to Earth. Now, this is the start of a very long journey. Now, we ended our last human exploration of the moon in Apollo 17, the 17th mission. Now, I hope someday my kids are going to be watching, maybe decades into the future, the Artemis 100 mission. Now, we're talking about a lot of repeated missions, humans and crew members and cargo going to and from the lunar environment. Now, the architecture you see behind us here with SLS and the Orion spacecraft is just the beginning. Now, over time, launching missions like this, we are going to learn a lot. And the vehicle architecture will change. And as it changes, we should be able to undertake repeatable, affordable missions to and from the moon. And in that same vein, just as we begin, the cost to undertake a mission like we're going to undertake with Artemis 2 is not inexpensive. But where it'll go as we learn and gradually incorporate reusability is what's going to enable missions like Artemis 100 and beyond, right? And why are we doing this? We are doing this to fulfill a promise to the American people that we will return to the moon, a promise to all of the pioneers, the engineers, the scientists, the astronauts, the researchers from the 1960s, of which laid the foundation that we are standing upon right now. We'll do it inevitably to figure out the orbital and lunar economy, for all of the science and discovery possibilities that are out there, to inspire my kids, your kids, kids all around the world to want to grow up and contribute to this unbelievable endeavor that we're on right now. And before I hand it over to Commander Weissman on this, I just want to acknowledge the contributions from literally the army that we have at NASA that shows up to work every single day to try and change the world. We don't do it alone. We have commercial partners, we have international partners that are involved in this, but we have thousands of people that have brought us to this moment. The thousands of people that have been working near 24/7 preparing us for this rollout, the thousands of people across the country that trained and prepared this crew to undertake this mission, the controllers that'll look out for them on space, the recovery crews that'll bring them safely home to their family at the conclusion of their 10-day journey. So with that, ladies and gentlemen, this is your NASA. Commander.
Thanks, Jared. Appreciate that. You said we're off to a slow start, but I heard Ike's going to go over there after this and drive, so we'll pick it up. The relative motion looks good, though. What a great day to be here. On behalf of myself, Victor, Christina, Jeremy, Administrator Isaacman, thanks for having us out here. And this is a great way to start rollout morning at Kennedy Space Center. I just want to build on what you just said about these teams. We see this beautiful hardware behind us, the SLS, the Orion. But for this crew, we've been on this journey for about 2.5 years, and we truly look at that and see teamwork. We see global cooperation. We see a strong nation leading the way. You look at those white boosters on the side. We've been out in Utah. We've met the men and women that are assembling them, that put them on rail cars and send them down here to the Cape. The core stage in the center, built by Boeing. Jeremy and I were there at Michoud when that thing got loaded on the barge and shipped down here with the RS-25s, tested at Stennis, assembled to the bottom of that rocket. The interim cryogenic propulsion stage, we met that whole flight control team out in Denver with United Launch Alliance. Building up into the European service module, we were in Bremen, Germany, meeting the Airbus team that has assembled that, and the European Space Agency, and then up to our Lockheed Orion. We spent so many countless hours in that vehicle preparing. And then you look just to the left here at launch control, it's almost eclipsed, well, it is eclipsed by the VAB. Charlie Blackwell Thompson leading her team and the exploration ground systems folks, that they have hit every single milestone for the last year to get to where we are today. They've hit every single one of them. It is awe-inspiring. And then back in Houston with our flight control team, led by Jeff Radigan and our launch directors, we really are ready to go. We were in a sim for about 10 hours yesterday, doing our basically final capstone entry and landing sim. We got in T-38s last night, and we flew here to the Cape to be here for this monumentous occasion. With that, I just really want to say thank you to all the press that are out here getting our message out. It's very important. And hand it back to Bethany. Thank you.
And with that, we will open the floor to questions. There is a mic over here on the left, and we ask that you limit to one question each so that we can get to as many people and questions as possible.
Hi, Marcia Dunn, Associated Press for Mr. Isaacman. What's your take on how realistic it is that Artemis 2 will take off in February? And if I might really ask Rita a real quick question, I loved your crescent moon shot recently. What's it like to go outside at night and look at the moon now?
So I guess take the first part of the question. I mean, we're continuing on with our Artemis 2 preparation campaign. I think we've held schedule pretty well, getting to roll out today. So we'll get out there. We'll put it through its motions. We'll get through wet dress. We have, I think, zero intention of communicating an actual launch date until we get through wet dress. But look, I mean, that's our first window, and if everything is tracking accordingly, I know the teams are prepared. I know this crew is prepared. We'll take it.
We like that answer. Going out and looking at the moon at night, I'll hand this all down the line. I'll be brief, but I think one of the most magical things for me in this experience is when I looked out a few mornings ago, there was a beautiful crescent in the morning sunrise, and I truly just see the far side. So it was a waning crescent here, so it's a waxing gibbous on the far side, and you just think about all the landmarks we've been studying on that far side and how amazing that will look, and seeing Earthrise, those sorts of things, just flipping the moon over and seeing it from the other perspective is what I think when I look out right now. Mike?
Yeah, thank you for that question. It is definitely different now. But it's also kind of like asking a kid how they feel about their homework. You know, it's a part of what we've been studying and training for. And I go outside, and now I think of it in a very different sense, that there's some scientific value in what we say about what we see. And we had a sim months back where when we walked out in the parking lot, Christina and I were standing there, and I had this overwhelming feeling that, like, wow, what science about the moon does in the future is going to at least be affected a little bit by what we say about that view. And so that has changed how I look at the moon since. And my dad asked me when we got a sign, do I see it differently? And I didn't right away, but I definitely do now because of the great team that we have getting us ready to do science. Nana?
I think for me, what I see is the fact that all the people here on Earth, when they look up at the moon during our mission, before our mission, after our mission, during Artemis 3 and missions beyond, all the way to Artemis 100, they'll know that not only have we been there in the past, but we actively go there. We send people there because we're humans that must explore.
Something I'll share with you. It was kind of neat. Over the New Year's time period, had a little time off, had my kids back at home from university, and we just had the best viewing weather in Houston for the moon, and it was approaching a full moon, and I had the kids out there, some mandatory science, observing the moon with me, teaching them landmarks that we've been memorizing as a crew, but they were lit up about it too, and that was just really fun. And I think the moon is something I've sort of taken for granted. I've looked at it my whole life, but then you just kind of glance at it, glance away, but now I've been staring at it a lot more, and I think others are going to join us in staring at the moon a lot more as there are humans flying around the far side. I think that's just good for humanity.
And with that, we'll take the next question.
Hi, thank you so much. TJ Mascaro with the Epoch Times. This question is for Victor and Jared. Looking ahead to missions like Artemis 100 and just the future of our space activities, a lot of talk seems to be around automation and computer pilots and all of that. I was wondering how important it is that we continue to build on manual flying in space, and what place will that have going forward?
An interesting question.
It's interesting. First of all, did you target me because I'm a little bit of a Luddite, and I love, the inceptors or the controls that I can, put my hands on if I'm going to fly something. But I think what the last 5 years has taught me since flying the SpaceX Dragon, the same one that Jared flew, is that the tool needs to be designed for the task. And so I could, go on and on about this, but I think it is something that we have to think more about because the state of technology is where it is, and we're not going to undo all of that. And so finding ways to integrate software, hardware, but the thing that hasn't changed, as far back as we can read the record, we are still the same stuff. And I've been reading these, there's a journal that test pilots put together, and the Mercury and Gemini and Apollo astronauts used to go and give these presentations. And I've been reading their reports, and they say the same things that we say, that, having a window is important. Having the ability to do critical functions is important. And just how we implement that, though, is going to change with the state of technology. Thank you for the question.
That was actually a pretty good question from the Epic Times. I'm
talking
actually
about
impressed.
an evolution in terms of what
that wasn't a bad question.
Manual inputs, right? So
pretty good.
I would say probably the T-38s you're flying, or maybe some of the last aircraft you've touched that actually, when you put a control input in. Aircraft you've touched that actually, when you put a control input in, you're actually directly moving a flight control surface. A lot of the fourth and fifth generation aircraft that are flown today, it's all fly-by-wire. So you're telling the airplane what you'd like to do, and then the computer's interpreting it and saying, this is what I'll give you. And I think you're going to just naturally see that evolution in spacecraft, right? We're not taking the human out of the loop, right? There can be some pre-planned waypoints as we navigate around the moon, and then perhaps a human is directly inputting this is the actual target location I would like to land at for some reason. The computer's taking that manual input and saying, now I'll put you there, right? And I think that's probably the evolution we're looking at. But no doubt, look, as we get farther into deep space exploration, the ability to rely on autonomous capabilities within the spacecraft become more and more important. And I'd say the moon is going to be a perfect proving ground for that, right? So we talk about building a moon base. Now, day one of the moon base is not going to look like this, glass enclosed dome city that we might imagine someday. That's certainly what the ideal end state would be, but it's probably a lot of rovers that are moving around, a lot of autonomous rovers that are experimenting with mining or some mineral extraction capabilities to start, printing with regoliths. So naturally, I think in terms of what we want to achieve in space, you're going to incorporate more more autonomy in our robotic missions. We're looking at a mission to Venus right now that could have some onboard AI capabilities in it. So this is the way we're going to go. But I'll tell you, if humans are on a spacecraft, they'll always have a vote. They'll always have a say in it. How that may look today could be very much like the F-22 versus the T-38 of the past, if that makes sense.
Dude, yeah. So, guys, Epic
And
Times
with
is
that,
not
we'll take the next question.
Epic Times is not a space news organization. That was a really technical question, considering they're kind of mainstream news.
Crew 11, I'm a pharmaceutical researcher, so I want to ask you about the science you're going to be doing.
That's Ken Kramer.
Tell
right
us a
there.
little bit, one or all of you, how it's going to benefit Earth and also how it's going to benefit us getting to Mars. Thank you.
Go ahead.
I think that's a great question. One of the reasons that these missions are so important is the discovery and the knowledge that we bring back to Earth, and that is the entire point. We have both lunar geology science and we have human research on this mission. Human research is that we're participating in, everything from how we can top perform, behavioral health, immune response in space, which is a fascinating physiological response that humans have to microgravity. And there's a really neat new type of technology we're flying, an experiment called Avatar, where we're actually using chip, organ on a chip technology, cell on a chip technology to mimic how our cells, our bone marrow cells, will respond to microgravity in the radiation environment, to bring that science back to Earth, to understand how we can more efficiently send humans deeper into space and how we respond. So it's really exciting. We're happy to be a part of all that science. And talking about the lunar geology aspects a little bit, the moon is like a witness plate for everything that's actually happened to Earth, but has since been erased by our weathering processes and our tectonic processes and our other geologic processes. We can actually learn more about solar system formation, more about how planets form maybe around other stars, more about the likelihood of life out there, starting with studying the moon. And I think that's something that question is, in my opinion, one of the biggest philosophical questions of our time. And I think some of the first steps to answering it start with this mission.
With that, we'll take the next question.
Good morning. Jeff Faust of Space News. Question for the administrator. As we're preparing to go around the moon with Artemis 2, I wonder if you can give us some thoughts on your plans for ensuring Artemis 3 can land humans on the moon by 2028. I know you've met recently with SpaceX and Blue Origin about speeding up the lunar lander development, but what should we be looking for in the months to come in terms of getting Artemis 3, keeping it on schedule, or at least ensuring a landing by 2028?
That's not a bad question.
Yeah, it's a really good question. So one, we will just continue to be, as transparent as we can as we make progress towards the Artemis 3 mission. The way the public can best follow on and probably measure progress is just observing launch rate. I mean, that is absolutely the key to, unlocking the capability that'll be necessary to bring our lander to the lunar environment and bring astronauts down to the surface. So. I will say I did meet with both Blue Origin and SpaceX on their acceleration plans. These are both very good plans. I would say they both reduce technical risk from where we were before, so that's good. But in the end, it's going to come down to launching vehicles very frequently to learn. Learn about prop transfer for sure, but you're going to need reusability in order to do that. So I'd say we're all, if we're on track, we should be watching an awful lot of New Glens and Starships launch in the years ahead.
And we'll take the next question.
I want that.
Good morning. Irene Klotz with Aviation Week and Space Technology. Sorry for the sun. For Jared, you've ridden a couple of rockets. You've seen launches and you've seen Starship up close and roll out. Could you tell us what you think is special about this rocket, and if your opinion has deepened or enriched in the month that you've been administrator?
Well, I appreciate the question. We need more questions for the crew over here, because they're the ones about to embark on a pretty extraordinary journey on that vehicle. I would say I mean not a whole lot has changed from my perspective, other than getting I guess a lot of firsthand account of the people that and the effort that goes into building a vehicle such as this. And even more of the history that led up to this, even just walking inside the VAB, which I've seen it. I don't know how many times from the exterior, and then you go inside. You couldn't even find the SLS in there if you wanted to. I mean, and then that just brings back, what it must have been like during the 1960s when you had multiple Apollo vehicles in there, or at a time when or multiple Saturn vehicles in there, at a time when you had multiple shuttles in there. So I'm halfway through a roadshow around the country to every one of our centers, meeting the workforce, trying to hear from those that are actually doing the hard work that it takes to pull off a mission such as this. So nothing changed in my mind about the importance of the mission that is NASA, our path to achieving it, but I've definitely had an opportunity to meet a lot of the folks that are helping enable it, and it's just extraordinary. So thank you.
We'll take the next question now.
Hi, Elizabeth Howell from Space Q in Canada, and this question is for Jeremy. You've often talked about how Canada has been taking all of these steps in space for decades alongside our international partners, clearly including NASA here, and you've also said, let's imagine what's next for Canada. And so in your mind, what's next for Canada in space once we finish this step? Thank you.
Thanks, Elizabeth. I would just like to re-echo some of those previous comments, because against the backdrop of that rocket rolling, it represents an extraordinary American workforce right there, watching that thing roll out. And like Reed was talking about, we've been around and we've met them and we appreciate them. And no matter what their future is, that's a workforce that is trained to do extraordinary things. And they'll be redirected as we adapt and continue to do extraordinary things. And that is the same story in Canada. I've really applauded the American space leadership because they carved out space for Canada to hone some of our skills, to develop workforce in specific areas and to bring that knowledge. And the future for Canada kind of looks like where the international collaboration wants to go. We aren't leading that collaboration. NASA's leading that collaboration, inviting our participation. We have skill sets, and I know Canada will rise to the challenge just like they did in the Artemis. When we were asked to join Artemis, we started to lean into developing new robotic systems for deep space. Even we're working on lunar surface stuff now. So we'll just bring that workforce to bear to meet joint collective objectives. And maybe I'll just end with, I'm actually pretty pumped to see that, because in just a few weeks you're going to see 4 humans fly around the moon, and if we're doing that now, imagine what we can do next. I'm pretty pumped to see that come to fruition.
We'll take the next question.
Hi, thanks for taking questions. Richard Tribou, Orlando Sentinel. This is for the astronauts. Sorry, Administrator. Tuesday is the 96th birthday of Buzz Aldrin, and there's very few all men, who've flown around or to the moon. I think we are down to 5, and they're all over 90. So, one, I know many of you have found inspiration talking with them. I know General Stafford was hand in hand during Artemis 1. So can you each tell me what the Apollo crew have been able to teach you about what you're going to face? And also, if you want to wish happy birthday to Buzz, feel free. Thanks.
Happy birthday, Buzz. I'll just share my General Stafford story, which was the day we all got assigned to this mission publicly. My phone rang that afternoon. I didn't have the number saved. It was a Florida number, and I was thinking it was a telemarketer. I was on my couch. I was getting ready to take a nap. It had been a long day with the media, and I almost hit the red hang-up button, but I just figured I would answer it. I answer it, and it was General Stafford. Reed, congratulations. We are so excited for you. And I think that's the way the Apollo crew has always been. They are so fired up that we are headed back to the moon. They are so fired up that we're going on to Mars. They just want to see humans as far away from Earth as possible, discovering the unknown, the near impossible, as the administrator keeps saying for NASA as our charter. So we really love that. I also want to say, we grew up in the shuttle era, and we grew up in the International Space Station era, and 3 of us have been up there, and Jared's been in low Earth orbit. He knows what that feels like. So we do feel like this is an Apollo legacy, but for the 4 of us here, we are standing on the shoulders of the International Space Station and the science, the research, the long duration exposure they have had, and what we have learned up there.
I mentioned how I'm reading these journal articles from the 60s about Gemini and Apollo and some of the engineering lessons and piloting lessons that they fed into the system. But something that's also very interesting that you just kind of get between the technical data is the people that they were. And I do find a lot of inspiration in that, just understanding some of what their families were going through, what they were learning, or what they didn't know they were learning. As we look back, we have the benefit of hindsight. And so I've actually been very fortunate to become friends with Rusty Schweikert, and Rusty gave me a bag of wisdom, quotes from different cultures all over the world that I took to the space station. And I'm going to take that little bag of wisdom, but also in my heart and mind, the wisdom that we've learned from Charlie Duke and General Stafford and Dr. Schmidt on what it meant to them. And some of the story that hasn't even come out yet. We're still learning things from the Apollo era. And so it'll be nice to take the baton, run our best race, and then hopefully pass that baton on to the Artemis 100 crew.
I think what they've taught me goes beyond the technical tidbits and things of that nature. And the biggest thing I can talk about is camaraderie. They taught me camaraderie because I've had the privilege of interacting with them for actually over 25 years now through a scholarship foundation that they give back to or gave back to. And then more recently at NASA Remembrance events, which are kind of little reunions in a lot of ways for the Apollo astronauts. And seeing the way they interact with each other, seeing the way they tell stories and the way they still love each other and being around each other and what they went through together and how that bonded them has been really instrumental for me in appreciating every single day with my crew and with the larger teams. And I will never forget seeing Fred Hayes at one of these remembrance events, shaking his hand, and before I even said, "Hello, sir, great to see you," he goes, "I heard you're going to break our record." And at that moment, he brought me into that camaraderie. And I made a promise that I will carry that forward and keep everyone in that spirit of camaraderie and carry it through our mission as well.
Apollo, just inspirational. I was inspired by Apollo as a kid. I think that's how I ended up here. I saw a picture when I was a kid of a human standing on the moon. It was either Buzz or Neil. But it just changed my perspective on things. I turned my Trios into a spaceship. I started exploring space in my imagination, and here I am all those years later. But for our crew, one of the required readings for this mission was Carrying the Fire by Michael Collins. And he does a great job of putting the human perspective in what was accomplished during Apollo. And it was pretty extraordinary. You were talking about it, Administrator, earlier, about what they accomplished during that time frame. And I think it's a good reminder for us. I mean, we're doing extraordinary things now, but we can create even greater things in the future. We should not accept this as status quo. We should always be striving for more. And something else you wrote recently, Administrator, that I think touched all of us was just the appreciation for, we want to fly safely in space, but we also have to be willing to take appropriate risk. That's what this is about. And when we were reading Carrying the Fire, this is the part that really got my attention. Michael Collins jumped on a spacewalk from one Gemini spacecraft to the Agena. That's extraordinary.
Yeah.
That is truly extraordinary.
Did some Martian stuff on that Gemini mission.
That was a courageous example, but they also weren't cavalier. They were taking calculated risks. And I think it's a great example for us to remind ourselves, hey, we're going to go out there, we're going to take some appropriate risk, and we're going to accomplish some extraordinary things. We're going to have some failures, some setbacks along the way, and then we're going to pick ourselves back up and keep going.
Good answer.
We'll move to the next question.
Hi, Kristen Fisher with The Endless Void. It's so great to see all of you on such an exciting day. You four are about to fly farther into space than any humans have ever flown, and with that comes some inherent risk, like you were just talking about, Jeremy. And so my question is, we've heard a lot about your training, but how are you training your loved ones? How are you preparing your families in these final weeks as you get ready to leave them behind on Earth?
Trying to train them honestly and openly is the best thing you can do. We just had all of our families together about a week and a half ago at the astronaut quarantine facility at the Johnson Space Center. That was one of the cooler moments in all of our training, just sitting around with our families around a conference table, and NASA was briefing them on the mission. Fellow astronaut Randy Bresnick, who was our technical lead, came in and gave them an amazing overview of the mission profile and the Orion spacecraft. And then there are the more personal touch points. I went on a walk with my kids, I told them, here's where the will is, here's where the trust documents are, and if anything happens to me, here's what's going to happen to you. And that is a part of this life. I actually wish more people in everyday life talk to their families in that way, because you never know what the next day is going to bring. So it's just important to be as open and honest as you possibly can. And then the other neat thing that has happened amongst all of us is our kids know each other, spouses know each other, we all text each other. It has developed this foundation that I know, even though it's a 10-day mission, I just know who everyone is going to lean on to get through this together while we're up there. On launch day, we've got the easiest job. We really have the easiest job. We've trained for this. We know exactly what to do, and it will be good. It's our families that we think about the most on launch day.
You know, it is an interesting part of this journey. We have the entire resources of our agencies helping to get us ready, but we have to take the initiative to get our families ready. And we have a fantastic family support team. But we do have to take some initiative and lean in on that. And so those are tough talks, but you have to have those talks, or they can be tough. And, you know, having the experience of doing this to get ready for the space station gives some neat experience, but also just something to compare and contrast with as well. And so we were having one of those tough conversations, and I mentioned to my family that, hey, you know, if I forgot to close the garage and we're all in Florida, I'll close it when I get back. You know, not 168 days later, but 10 or 11 days later. And so we you know, that is an important part, and thank you for bringing that up, because it is something that I think about a lot. And I am also really grateful that we have. I was actually just talking to Jared's family about when we were here to watch the Polaris launch. I was here to support a colleague and their family while they watched their loved one launch. That's my favorite role in this office. That is my most cherished, honored experience that we get to do with and for each other. And we have some folks that are going to be supporting us. Two of them are here, our backups, Jenny and Andre. And we have escorts that are assigned to each of our families. And I just wanted to give them a shout out. We've all got someone, an astronaut, that is going to be with our family members when they're watching launch, which can be this terrific and terrifying moment all at the same time. And so I'm just really grateful to that team that helps us to get ready.
I think for us, in addition to all that, it's two things. First of all, I love talking to my husband. He's been very inquisitive about the actual technical aspects of the mission. These guys know my husband. So, you know, we're talking about what are the big milestones? What are the risky parts? When can he sigh a sigh of relief? When does he need to be glued to the TV? And talking about some of those technical things, every once in a while we just get a question that comes out about the vehicle or how the mission's going to go. And then the second one is just a little more practical. I really have to make sure he knows that it's not like the International Space Station where we can just make a phone call. So he's not going to be able to call me and ask where something is in the house. He's going to have to find it. That's been a big one for us.
Oh, dear.
Pretty similar for my family. Over the holidays, though, we did watch some Artemis 1 launch video and entry video just to kind of point out a few things that can catch you off guard, like when the main engine's light. It does look like for a few seconds a rocket is blowing up, and then it launches. So letting them know about that. Also, the re-entry, what they can expect to see and maybe not see and not hear from us, and that's normal, and there's just a lot of different stuff there. And so during those times, just be calm and patient and not make any assumptions. And then the other thing I told them, maybe this is good for all of you, is during the mission, you know, it's the first time we put humans on this rocket. And so we've done a lot of testing of these systems, but when we get to space, we will probably see signatures that look a little bit different from testing. Maybe not a lot different, but a little different. And then the team is going to do what the team does. And they are going to worst case scenario everything. And so if you hear any of it, it might sound really bad. It's probably not that bad. We're just going through what's the worst case scenario, what's the next worst failure. And that's probably going to be par for the course on a mission for the first time with humans on it.
Can I take a little license here and I want to just say something to you all. Thank you for being here and helping us share, you know, all of this perspective and time with and gratitude with the world.
Pleasure's on
but
this
you
side
all
of the
have
table.
a really unique role. And what Jeremy said just reminded me of this, you know, how we talk about this is going to be based on how we think about this, what you believe. And this is a test mission. This is the first time. If we aren't pointing the thing right exactly at the spacecraft, we're not going to get that high definition downlink. And we could go, oh, darn. Or you could say, this is hard. And they're safe. And they're going to be back here in a few days. And so how we talk about those challenges, how you all talk about those challenges is going to affect how the world sees this. And what we're doing is we're swinging for the fence, trying to make the impossible possible. And so I would just encourage you to think about that as we all go on this journey together in a few weeks.
And with that, we'll take one last question.
Will Robinson Smith with Spaceflight Now. Thank you for the opportunity. You all had the chance to go down to the pad when the ML was there. You've had the chance to get up into the rocket when it was inside the VAB, but pretty soon you'll have the chance to go back to the pad with your rocket and spacecraft there. I know you are liking to stay, focused on the mission and preparation, but can you imagine for the rest of us that don't have that experience of what that day will be like, the first day you get to go out to the pad when your ticket to ride is there? Thank you.
I'm going to start with the simplest human element, which of course it's going to be amazing and all that, but I want to reflect back a month ago for our countdown demonstration test. We were in the vehicle assembly building. We were in Orion. Everything was fully powered. I was the first one to get in the seat. Ike gets into seat 2 next to me, and I was like, Ike, look, the dim button works on the display. And he's like, no way, because in our sims, that button doesn't work, and we can't dim the display at all. And I just want you all to remember, we are 4 human beings getting in this magnificent spacecraft, and sometimes the simplest things put a huge smile on our face.
Bro, it dims. No way.
That human piece, I actually try to keep a lot of that
That's
to
awesome.
myself. I think there's a time and a place for it, and so excitement, for example, is something I get asked about a lot, and I don't let that out often. I think it can become a distraction, or it's a long story. I won't share with you now, but I can tell you this, having walked out to 39A and saw a Falcon with a Dragon sitting on top of it, there was I'd say 300 milliseconds where I thought, I'd just be embarrassed if I walked out of this and said, I'm not doing this. That's crazy. But then I stood there in awe that, wow, we're actually about to go fly that thing. And then when they got to 10, 9, it was like, oh, no, we're going to fly it now. And so I actually look forward to that, even though I am focused. I'm glad you started with that. I am focused. I'm not excited. I'm focused,
Locked
but I
in,
look
baby.
forward to a moment like that with that beast.
As astronauts, one of the qualities that we talk about a lot is adaptability. This idea that, yes, you train and prepare for everything, but the most important thing is that you're ready to take on what you haven't prepared for. And so one of the things that these 12 years I've had in the astronaut corps has trained me to do is to not have expectations. So today is a day I trained myself not to expect. But looking over there, that's an amazing feeling. I think that on the day when we climb in, I always have heard this adage, and it turns out it's true. Astronauts are the calmest people on launch day. And I think we do that. It feels that way because we're just so ready to fulfill the mission that we came here to do, that we've trained to do. We are so ready to just give back that it gives us this intense feeling of calm and readiness. And I hope and try not to expect that I will feel that way.
Last time we walked across that pad for the countdown test that Reed was talking about, and you go up the first elevator and you're on the bottom of the launch pad and you walk by the bottom of the solids and the 4 RS-25s, and even in that moment, it wasn't fueled and it wasn't creaking and moaning and it didn't look super scary, but in that moment, one of the things that I felt was gratitude. And I just see people when I look at that rocket. And people have poured their heart and soul into this vehicle, and it's truly extraordinary. And they're 24/7 here across the country, around the world. People are just pouring their hearts and soul into doing this because they're fired up and inspired by what we can accomplish. And so I know I'll feel a lot of things on that day, but there will be a fleeting moment at least of gratitude.
And we are actually going to take just one last question, and then we will wrap this up.
Yes, thank you. There we go. Thanks. Sorry, a little short. Sawyer Rosenstein with NASASpaceflight.com. I know one of the key things about this mission is the human factor of things, and I know you each get just a little personal kit that you can bring with you. Is there something special or sentimental that each of you is bringing with you that you're kind of proud to say, I brought this to the moon and bring it back to Earth?
That's a good question.
I have a blank piece of paper and a pencil, and I can't wait to write some thoughts on that. I don't know what to expect, and I don't want to go in with any preconceived notions, so I know exactly where that note card is, and I can't wait to jot some notes on it.
My Bible and my Bible, if that didn't go on the microphone, and an heirloom for each of my daughters and my wife.
For me, it's handwritten notes from people that I love. The idea that I can hold in my hands way out there, or in my case in the past on the International Space Station, I can hold in my hands something that they held in their hands and drew on or wrote on. That is really special to me. So I hope to find some in my care package when I get there.
Some things that definitely represent the people that put me in this position, but one of the most meaningful things is the 4 moon pendants that I gifted my wife and 3 children, I guess 2 years ago now, and they wore them for a while. I collected them back this summer, and they're on that vehicle right now, rolling to the pad.
We will conclude today. Thank you so much for coming out and for your interest in NASA. And thank you to the administrator and the crew for taking the time to answer these questions. Just a reminder that we will have a follow-on press conference and media availability with the acting deputy director or deputy associate administrator of ESDMD at 10 a.m. at the KSC press site. Thank you.
That was good. Were you blind, odd, dumbstruck? So that's it, guys. A2's rolling to the pad, and you know, hopefully that's the last time it comes out of the VAB. There's going to be no rollback for this thing. That's on the pad, and NASA changed the processing flow around to not have to roll it back after wet dress rehearsal. So it's going out there, and it's staying out there. You know? Yeah, fingers crossed. That Sawyer's question made me really happy. That's cool. That's cool. I like what Reed said. Just a blank note card. Yeah, dude, that's good. That's good. You didn't know Sawyer was in a wheelchair? Yeah, Pigeon. Mm-hmm. Yeah. Who was that next to Sawyer? I don't know. The only rollback would be due to weather, but hey, that's not positive vibes, W. Positive vibes. Look at that freaking thing, dude. What a day. Would Bible be pushing the weight limits on care packages? Nah. Joe, no. The pocket Bibles, if you got like a paperback one, they're super light. It's just a book, man. Books aren't heavy. It's light reading, okay? Yeah, no problem, Zeros. Yeah. Look at that monster. We gotta make more of these things. Make more of them. Come on now. I know, Badojo, that's where I'm at too, man. I can't believe this. We're here. That thing's sending people to the moon. You know, God willing, in less than a month. How did we get it? Like, wait, when did this happen? Like, that's been something I've been thinking about. I said this on Flame Trench yesterday. It's something I've been thinking about since I could rationalize the concept of what spaceflight was since I was a little kid. I'm like, wait, we haven't been to the moon in a long time? When are we going back? When are we going back? Like, now. Now. I like space. More space, please. Yeah, I'm kind of with you on that one, dude. I'm happy we get to see it, man. Honestly feels like it came out of nowhere. Yep. Guys, you know, I got asked a question a little bit earlier on stream from Marcon. Hey, Ozzy, what's up? Feels like we've been waiting for this moment for a long time. Yeah, for sure, man. A viewer asked me a question like, people aren't hype on it. People aren't hype on it. Dude, here's the thing. High-profile missions like this tend to have a profound effect in the moment. So what does that mean? You know, Reed Wiseman said in that press release, like, he doesn't know what to expect. And honestly, that's right. Dude, we can sit here and we could say, look, there's a moon rocket rolling to the pad that's going to have people on it that's going to fly by the moon. You know, the regular viewers here understand what that means. All right? But even for us space nerds that do it, let alone the people that don't know too much about space that are watching, thank you for watching. I do appreciate it. When you see this thing go and you see the shots from out at the moon, it will affect you in a profound way that you were not anticipating. I guarantee it. And what I really am hoping for is that people will see the benefit of NASA doing missions. NASA doing this stuff. It's a different ball game, man. It's not like commercial launches. And some space flight fans out there, that's all they know. Some of you guys weren't around for the time, like during the shuttle program, like how special a shuttle program launch was. And it affects you in a very profound way. And that's just the space shuttle. It's just going to the ISS. My hope is that people will see how special it is when this thing goes and how much of a privilege it is to see something like this in our lifetime. I really hope people will see it because it's special, man. This is stuff I dream about every day. I look at the moon when I stop streaming at night and I walk outside from my shop back to my house because my office is not attached. I have about, 100-meter walk through the woods back to my house, right? My garage is not near it, right? It's back in the woods. It's like, so I walk down this like pathway with a bunch of trees around and stuff. If there's a clear sky, I look at the moon and I stare at it. Sometimes I just sit there and look at it. Personally, I've been dreaming about this for a long time. And a lot of people out there have been dreaming about this moment longer than I've been alive. It's special, man. Enjoy it. This is good stuff. Yeah, Nader, there you go. This is special. This is us at our best, man. We got to do more of this. Is this one sitting on the upgraded launch platform? That's Mobile Launcher 1, ARJ. It's not ML2. Yeah, Waxy. We need a W. And that's what I'm hoping people will see. Because right now, like, it doesn't feel like we're going back to the moon in a month. But we are. And once again, it will profoundly affect you if you watch it. If you understand and your brain tries to rationalize what's happening, it'll hit you in a way you weren't expecting. It always does. It's so freaking cool. This I live for this stuff, man. This is what keeps me going. I sit here and I do 10-hour streams. I love playing games and stuff, but spaceflight is that's my motivation to do that. My motivation to be here and tell you guys about space, even if we're not playing a game that has to do with space, just teaching people about stuff. And this is what drives me, man. Stuff like this. Look at it. Oh, it's so cool. Yeah, Perry, that's a good thing, man. It's a good thing. It's just... I would ask, what song are you bumping in the van? I don't know. If I was the commander of this mission and I was in the van, I'd probably play Tom Sawyer by Rush because Jeremy's there, because Rush, you know, that's a treat. Thank you for being such a great teacher. My son 11 came and sat and watched with you for like 10 minutes and he loved it. Awesome, Kenwa. I'm good. Yeah, that makes me so happy. Look at that thing, man. Corpa? I would not be listening to Corpa. Look at that. Look at what we can do. Isn't that awesome? Brings a tear to my eye. Lars, you're happy that the ESA has had a quite large contribution to this. Obviously, NASA's the main engine, but it just shows how much we can gain by working together. Yeah. Yeah, you guys are pulling your weight with that service module, for sure. We just got to build more. You got to build more of these things, dude. I'm telling you. Commercial missions are awesome, and it's so fun watching a Crew Dragon launch with you guys. It's so fun. This will hit, I'm telling you, this will hit different. It's a totally different feel. It makes you feel so damn good. You know. I'm telling you, I cannot overemphasize this. You watch this launch with me. Or don't. I don't need, just watch the launch. It'll, I'm not saying it's like profound enough to be like life-changing, but it is for some people. It's just, oh, it's so cool. And like I said, I'm hoping that people see how worthwhile it is for NASA to have their own in-house space program as opposed to commercial. But if I don't want to watch it with you because I'm watching in person, that's why I said or don't, whatever. I would watch it. I would watch it in person over watching me too. I know. For sure, Hooper. Every shuttle launch was special, guys. There's a reason why, you know, some of the older spaceflight guys around, like me, Crispy, Sawyer, we love this. We love the space shuttle, dude. There was nothing like a shuttle launch. Nothing has come close. Starship has come close, and Falcon Heavy came close, but nothing. The shuttle launch was like nothing else, dude. And I'd pay a good amount of tax dollars, and I don't like paying taxes. The whole thing, you guys, if you know me, but the whole thing with my accountant, right? I'd pay a good amount of tax dollars to capture that feel again, and I hope this thing does it. I think it will. Moon. Why not watching it there live? I'd rather watch it here with you guys, to be honest with you. I would love to go down there, Squall, but I don't know. I would really love to cover it with you guys. Here's the thing, guys. I'm too close. We're too close to the launch. NASA closed press credentials like a month ago. So I can't, if I go down there, I can't cover it with NSF. So that's what's really weighing on my mind. Like, yeah. Hey, Marco, do you know if we get live views once they are in space? Yeah, we'll get live views. Yeah, it's not gonna, not the entire mission is going to be live all the time, Marcon, but yeah, we'll get live views. It might be a little, we're probably not gonna get the best quality images live streamed from Orion when it's around the far side of the moon, because there's a moon in the way. But yeah, they have high def cameras all over this thing. The shuttle made you feel like you did when you watched Apollo. Yep. I hope young kids are watching it. Well, if you're a parent and you have a young one, show them this. My dad showed me shuttle launches when I was very young. And I've loved space since. Like, I don't know what that's about. Like, why don't they have some relay sat in orbit around the moon? They're working on it, NX. That's what Gateway's kind of supposed to... Bird? That's what Gateway's supposed to do. Gateway's supposed to be the relay sat for the moon base. And then Intuitive Machines is also working on a communication network as well. Basically, TDRS for the moon. I got into space from the We Are Going NASA video 6 years ago. Oh, Hinris, that's such a good video, dude. That video gets me fired up. NSF will be there. You can't stream with them on site. No, Squall, they closed press credentials. Do we know when the launch with? It's no earlier than February 6th. Right now, Josh. I'm sure someone can make it happen. No. Squall, I've already tried. And I have a lot of connections at NASA. I've already tried. Trust me on this one. Yeah. If there was any chance, I would have gotten press credentialed already. They're being very, very stubborn, like about closing press credentials. But when they close, like I said, they closed badging in 2025 for this mission. So, I can't. It's okay. I'll cover it here with you guys. It'll be fine. We'll just go down for Artemis 3. It ain't no thing. I didn't get into space really until Bob and Doug's mission. Before that, I just thought it was neat. Gotta be honest, you have a lot to do with my current interest. Sorry about that. Believe it or not, Starship Flight 1 final prep campaign got me into rockets. The first thing about rockets I saw was Booster 7 33 engine static fire, and then I saw Flight 1 in English class with your classmates. That's good, man. I always say that launching is what gets people invested in it. No amount of STEM outreach can replace a rocket launch. There you go, friend. Right on. Wait, because you don't have press credentials, you can't cover the launch on the NSF stream even from your house. No. I can't go down there. I could do stakeouts for them. Yeah, sure. I probably will. That's how it's probably going to play out, Drew, like Starship. I'll probably do the stakeouts for the launch, and then, you know, the NSF does the launch coverage, and then I'll just cover it here. It was that conversation, the topic of discussion is about going down there versus not. I can't go down there and cover a launch with NSF because I don't have press credentials for the press site, because they went really hard line on it when they closed the badging. Dumb question. Was Artemis 2 scheduled for this soon to take part? Because I didn't think moon landing would happen this fast. Artemis 2 has been on the books for a long time, Pigeon. This is not a moon landing. They're going to fly around the moon. It's a shakedown for the Orion capsule with people on board. They're not going to land this time. Jim, I can get down there. That ain't no problem. Like if I had a press badge, I'd sleep. If I have to sleep in the car, that's fine. And take showers at like my buddy's houses down there. Like I know tons of people on the Space Coast at this point. I'm sure one of them would put me up if they, you know, if I asked. But I don't have press credentials, so it's not worth it. If I had a press badge though, oh yeah, I would go. I don't care if I have to sleep in a car. I'll sleep in the pickup bed of one of my trucks. No problem. If you route 154 to Artemis 3, Fred Coronet or the F2 Shifty? If the Coronet's done, I would really like to do that in that. That would be pretty sick. Yeah, Joseph, that's probably it, dude. You know, Joe, I'm just going to go out on a limb here and say I'll bet you the president shows up for the launch. Some people might not not like hearing that, but I'll be very truthful with you. The president showing up is going to get more people to watch the launch, whether they like him or not. That's better for space outreach, and that, in my mind, trumps everything else. I'll bet you he's going to show up. Joe, that's a good point. That's probably why. You know, you said it's like a White House event. He's probably going to show up. Why wouldn't he? He showed up to DM2. Do you remember that? It was DM2, right? I think it was. Trumps everything else, pun intended. Not really, Crom, but yeah, you get it. Yeah, that's right. DM2 scrubbed. That's right. That's right. Yeah, he showed up for the first attempt, so he was there. And guys, like, once again, you know, that's not necessarily an endorsement or not an endorsement of the president, right? Like, what I'm trying to tell you is that if he shows up, that's going to get a lot more people. That's going to increase visibility of this launch tenfold. Because wherever he goes, all the mainstream media goes with him too. That means every if he shows up to this, every news network is going to cover this around the freaking world. That's good for spaceflight, whether you like the president or not. That's correct, Weather Guy. Can we calculate what time of day they will need to launch? Not calculate, Mile. It's going to be a night launch. They got to launch with the moon in the right phase. So, Bird. They got to launch with the moon in the right phase. So, it's not... The moon has to be in the right place. So, it's most likely going to be a night launch. There are some daytime launch opportunities, but it's most likely going to be in the middle of the night. It doesn't... So, like, I know people are going to ask, like, why launch at night? Why launch during the day? Why not launch during the day when everybody can see it? It's really not about whether it's light out or not. It's, like I said, whether the moon's in the right place or not. That's really important. This is about astrology. No. No. It's about orbital mechanics. The moon has to be in the right place. Think about it. Think about SLS going to the moon. If you're not familiar with orbital mechanics, think about SLS going to the moon. The moon's a long way away. It would be like if you had a gun and you were trying to lead a target. All right? If it's not in the right place, your lead is going to mean nothing. And you miss. You do not want to miss. If you miss the moon, you're not coming back. Let me put it to you like that. Moon's got to be in the right place. They have to make sure they lead the target correctly. Yeah, Demon, I don't. Foxtrot's like, I played Kerbal Space Program, so you should be an expert on this. You should be an expert. Yeah, Aquamori, pretty much. Mercury being in Powerade and all that. Oh, yeah, Myers. Yeah, that's important. All right, guys. Well, they're going to roll it out to the pad. That rollout's going to take 12 hours. I mean, I'll be honest with you. I would do it. The whole thing. But I do have some other stuff that requires my attention off stream to do today. So I do appreciate everybody watching. Thank you very much. But this is where I'm going to pack it in. I always ended up at Duna instead. Oh, so you missed. So thank you very much for watching. The next stream will be on Monday, guys. we'll, yeah, the next stream will be on Monday around noontime. Nah, I'm good, weather guy. We're good. Pleasure as always. Thanks for the stream. Yeah, thank you very much for watching, guys. And just remember, enjoy this. This is a good thing. Don't let your mind tell you that this is a bad thing. This is a good thing. This is a good thing. I cannot stress this enough. This is going to be an awesome mission, and it's a treat and a privilege to be able to see it. Don't let anybody tell you anything different. Okay? Good stuff, man. Good stuff. With that being said, thank you very much for watching. And thank you, NSF, for letting me show the footage and their footage of their stream. They're still going. So what I think we should do if we're going to raid anybody is just pop over to their stream, guys, if you want. I'll link it up in both chats. Go over there. If you want to keep watching the rollout coverage, go watch my buddies over at NSF. Thank you very much for watching. I'll see you guys on Monday. Have a great weekend, okay? See you later. Thank you.